Okay. So today, what I think we're gonna do is, so I got most of the stuff, and I'll show it in a second. But uh, so I found kind of, uh, yeah. There's this, which uses a belt, a servo. This is a pretty good one. This one's great, and then this one. So these are the three that I'm sort of using. I don't know about this one. I didn't really watch this one. This one's great. This one's interesting because it uses a rail and then two bars with a little set screw, two beams. So just to show you guys what I got. So I got the rail for about $30. It's I closed it, but it's this. So we're gonna CAD that out. I got a belt, GT2 belt, 6 millimeter timing belt, whatever. I got the CNC breakout board, and you know what's crazy is this was like $10, and it came with the stepper drivers, which I thought was crazy. Fuck whatever. And then I even bought. Oh, and then here, this is another thing. So I got these. These are pulley wheels. So this will go into the shaft of my stepper motors. I think that's it, pretty much. So, but for right now, we're just gonna CAD this out. So we have the MG. So wait, we want to do this. So so we're in this column, and the only thing that's different really is the force calculations on how much it can handle, and the block. The C has a different size block. So I think what we're gonna do is we're just going to. So I would love to actually. Should we do it in zoo? I really kind of want to do it in zoo. You gotta be careful. They have sweep now. I mean, the thing is, wait, what's going on? There we go. With freaking O3 coming out, I'm really like, all right. I mean, Arc, Arc was the thing that I thought was like, it's just incredible. It's just incredible to think about. So it's like, what do we even really need to do anymore? I mean, I kind of just want a pen plotter, so I'm just gonna build it. But it's like, what do we even need to do? This video is awesome. This video has a tool changer, which is really cool. But yeah, so we're going to be using Arduino, unfortunately, because the thing is, it just doesn't seem like Raspberry Pi CNC is nearly as well supported as GRBL, which I think has been updated. Anyway, so what did I do? I downloaded Zoo, but let me just do this really quickly. Okay. So, because the thing that would be nice, honestly, I haven't done enough Zoo. Um, Wait, hold on. Let's undo this. See, how long does it take to get... How usable is this thing again? There we go. Okay, um... So I got the desktop app. That should hopefully, uh, there's this. This is an example of a custom domain-specific language called Kitty, and it's specifically for CAD. And what I want you to do, wait, where is the image? The image is a bunch of dimensions, and what I want you to do is make variables, and don't use the variable names that they use, but maybe include them in the names. And what the row of dimensions that we're using is the MGN15C. And so I just want you to make the variables. You don't have to actually write the CAD code. I don't think you could do it, but at least get the dimensions. We'll see. If not, I'll just do it in Onshape. Because the only reason, honestly, why I even care about Zoo is just that language models could write it. Plus, I don't think I have. $16. I don't know why it's naming it var. That's silly. All right, let's see how far we can get. Honestly, I kind of don't even want to do this. But at the same time, well, okay, let's do both. Let's do both. Okay, so the thing that sucks here is that there's no way to like import a CSV and make it variables. So that means we have to like write it all out. Let's just see what happens if I paste a table. All right, let's just fucking do it. What's G? No way, that's not right. What even is that? I don't even know what G is. What's GN? Do you see GN anywhere? Oh, really? That's threaded too. And 3 MXL. Where is that? Wait. MXL? I don't see that anymore. All right, whatever. Let's just keep going. Oh, wait, L, G, GN, MXL, H2. What's H2? Okay. Is that a center line though, or what? Some of these drawings a little hard to read. Does it have I don't see the dimension to the slot there. Whatever. I haven't done CAD in so long. I'm just trying to embarrass myself, I guess. Okay, this is the rail. WR, HR, D, H, D, P, E. These names are so ridiculous. Mounting bolt for rail. M3 by 10. So how do we want to design this thing, man? I mean, the rail is one. Okay. We have all of the things now, so we can. Okay. Oh wait, we didn't actually fucking write them all down. So 16. Oh great. 4, 8.5, 32, 25, 3.5. What's B1? Oh, B1. Okay, wait. So what is the... And the total is W? Okay. C. 20. Okay. L1. 26.7. I don't know if I should test any of these. I feel like there's no way that they're wrong. Who comes up with the MGN spec, by the way? What is L? L is the... Okay. Okay. I found some stuff. Oh, I actually found some stuff already. Whatever. But just prove that I know how to CAD if need be. M3, so we should just make this 3. Oh, it's H2. H2 is to the center there. Okay. WR 15 10 6 4.5 3.5. So that has some clearance on it. P is 40 15. And then mounting bolt for rail. They're pretty much all 3. Okay, and then none of the load stuff matters. So we should be able to... So how do we want to start this? So there's gonna be 2 parts, right? The carriage is gonna be the more annoying part for sure. It's kind of mesmerizing to watch it. Okay, so let's just get started. So number of holes: 1, 2, 3, 4, 5, 6, 7, 8, 9. NH is 9. Rail len. This is going to be. Is there a 15 here? W. It should be E. E is 15, so it's going to be 2 times E plus and wait, 2 times E plus NH. Oh, and this is actually not a, it's a number, and it's not. Plus NH times, and then what is the hole spacing is going to be P. See, that says that this thing is 390. Don't I have a ruler somewhere? I think I put the ruler back. I need a little tape measure somewhere. Let me go get a tape measure. Okay. 13 3/4 inches. See, that's 350. So I don't know where I'm getting this fucking math from, bro. The hole, what is the hole diameter? That's D. It's a big D. So it's gonna be 3. It's gonna be, no, it's gonna be 6 plus. I'm guessing the hole spacing actually is 40, but yeah, the hole spacing is 40. But then where am I getting my math wrong? Because wait, 390 minus 40. Oh, 1, 2, 3, 4, 5, 6, 7, 8. Because there's 8 spaces in between them, so you actually need a minus 1 in there. Okay, there we go. I'm a dumbass. Okay, so we're good there. So then we have the rail length. So I think, I don't know how important this geometry is. I guess let's figure out the depth of this thing. The thing is, it's grooved a little up. So why don't we do this? I think I can get it with the blades. So that's 11.5. And the rail is 15. And then 2.5. There isn't a lot dimensioned on the rail itself. What did O1 say? I wonder who came up with this. Yeah, I think I'm gonna make it a V groove. Even though it's not. The carriage is gonna be so annoying. Okay. Some of this stuff is, I'm sure, a little weird. Okay. So obviously what we want to do is we want to come up with a sketch. And how do we want to do this? We kind of want it to go like, wait, can I fucking, okay. So it's gonna go like this. And then can I select this line? So it's going to be all of this mirror there. But see, like we kind of just don't want this there. So why don't I just undo the mirror? Guess I can't undo the mirror. The hell. Alright, so let's just delete it. Fuck it. I'm just gonna start it over. So it's gonna be like so this is the okay. It's gonna be like this. What the hell? That's equal. Oh wait, and I messed this up. This needs to go in. What the heck? Just delete this. So this and this are equal. This and this are. These are all equal. Okay, this should be centered. Okay, so let's get the heights. So we're gonna need to look at this too. And I see they have this H1 or HL, whatever it's called, but they don't have. They don't really have any geometry there, so that's why you need a caliper. So okay. So it actually, I mean, the geometry is more like this actually. If we were to be for real, why can't I? Oh my goodness! Stop. It actually goes like this. But I don't know if we want to do that. Oh wait, I think it's an H. What? Oh, okay, that's good. Okay, so it's like this, 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 this. And these are equal. Oh wait, but I still again messed it up because this and this. First off, I don't actually know that they are the same, but I think you can assume that they are the same. But it's going to be like this, and then this, and this is a vertical line. And then it's going to be like down, and then across. Okay. So I don't know how many of those I really want to specify. Let's just get the big ones down. So the total thing is the distance from here to here, and this is measured as h. So this is just h. And I don't know, I thought I was getting 15. I'm getting 10. Oh, that's to the top of the... Yeah, see, this is all... Oh, wait, HR. It's HR. Where's HR? Yeah. Here we go. Okay. That's 15. And it's WR. So the distance between here and here. Actually, wait, do I have to do it like that, or can I just do this? This is WR. Okay. So we're starting to get there. Now these are equal, right? And then I want to dimension this to be, and I don't think we're going to get any of that. So, 6.5. 6.5 plus 2.5, that's not right. Oh yeah, that's right. So, and then the channel is 1. All right, so let's do that. So so the distance between here and here is 2.5. Okay, let's move this down. The distance between here and here is 6.5. Okay. Then we want to make these equal. Oh, great. I don't know why that messes it up. If I just make these two equal. Okay, and then we need to know how thin the channel gets. Like 11. We'll say 11. That means that 15 minus 11 over 2 is 2. So what does that mean? That means that the distance between here and here is 2. And then, I don't know, I would say that this is 1. Close enough or what? I don't know. Let's just do it. I feel like this is not the most important. So this is 1. Wait, but wait, we want to make variables for all of this, right? So, just so that people can customize it later, maybe. So, this is going to be notch straight. And we're going to write documentation for this. I want to make this, like, nice. Like, this is going to be a standalone document that's just an MGN rail with a carriage on it. Because I just want to accomplish something. And this is going to be 1. And, what did we say? Top to notch top. 2.5. Bot to bot notch bot. And this is going to be 6.5. Okay, so what we want to do is bot to, and then we want to do this as top to. Okay, then this 2 is notch inner to rail outer. I'm going to call it 2. Because if I measure the thinnest part of the rail, I get like 11. So then that means that 15 WR minus, you know, whatever. And then this, what is this? You should be able to, okay, so I can drag around this. So let's try to get that. Might as well. .75 or something. So, bot to notch angle start. Notch bot angle. I don't know. These names are always so stupid, but it's what was it, 5.75? So that's what this is. Bot to notch bot. Okay. So now we just need to copy that over here. And I wish I could just automatically do that. Wait, maybe I can't. With just a bunch of equals constraints. Wait, what if I just delete all of these sketch attributes and mirror them? Okay. Mirror. Okay, cool. So this is this. So we did it. So now, and it's fully constrained. And it's all parameterized. So now what we want to do is we want to extrude this. And we want to extrude it to rail len. And then that gives us the 350 millimeter rail. Okay, so now we just want to add the holes. And the holes are pretty well defined. So we're just going to sketch on here. And then we're going to do a linear pattern. So we're just going to do a C. And we are going to diameter this to D. Then we're going to diameter this, or not diameter, we're going to dimension this to be, this is E. Okay, then we want to take this, extrude it, remove, and it's going to remove H. So it's going to remove H. Okay, it makes it so easy when they give you these dimension charts. It's one of those things where it's like, AI could obviously do it, man. Such is life. Life is pointless. But I do want to plot some shit. Because the thing is, I realized, okay, it's going to be really hard. It's going to be really hard to do the Nerf shooter to paint a painting. But if I want this image from SICP cover... This is from the freaking... wrong one. If I want to do this, but instead of a lambda, I want a plasmid. But I want like a beautiful looking plasmid, not one that sucks. I want a pretty picture of a plasmid. Anyways, I'm going to put a plasmid there, and it's going to look sick. Alright, so on here, we're going to sketch on here. We're going to draw a circle at the center of it, concentric. This is going to be dimensioned to be little d. And this is going to be a remove, up to next. Okay, great. So now we can take take this linear pattern. Entities to pattern, it's going to be... Wait, entities to pattern. Wait, it's not a part pattern, it's a feature pattern. And it's going to be these two features. And the direction is going to be like this. Oops. Okay, the distance. Isn't there a way to... So the instance count is going to be NH. Distance is going to be a P. And then we just want to flip it around. Great. We got the rail. The rail was easy. The harder part is going to be building the carriage. And what I'm thinking is, should we build the carriage in here, or should we build the carriage as another part and then make an assembly? So, none of this is well defined, right? Like, what is that bump there? I don't want to take it off though, because I'm gonna drop all the bearings. And then this whole project is kind of ruined because then I have to order another one. And I'm hoping that I get to print some stuff today, because I don't want to just like this guy, he released all of his CAD files. Oh, and by the way, I do have some springs. And so he said you need some springs, and I knew this was going to come in handy to buy some springs. The problem is I don't know if... Yeah, see, okay, so we do have some springs that are like... And I'm guessing that there's a whole specification standard for springs that defines their geometry, their force, basically probably based on the gauge of wire that they're using. So I got a spring set. Yeah, these are almost maybe too much. So we'll have to figure out how we want to handle this. I've never worked with springs before, so it'll be an interesting go to challenge. Oops. Well, anyways, let's just keep it pushing. So we're gonna I'm thinking we use the same part studio. So no, I'm no. So this is gonna be called the rail. Wait, so let's just rename this to be MGN 15 linear. Okay. This is going to be a part studio, and it's going to be named MGN 15C care. Okay, great. So how do we want to start this? I'm guessing. That doesn't go all the way through, right? Do I have like a this too? I wish I had like a long skinny thing to see. Oh, like a wire. Or like this. This works. Oh, see, that does have a depth. And then maybe that's actually specified in the drawing. Yeah, right. So wait. Well, there's that. There's that. I don't know what that G is, man. That G is like not a thing. But is it it might be specified in here. I just don't know it. Let's see if I can measure it with my caliper. What the hell is going on? There we go. There we go. Six? Is there a six anyone here? D? That's D. I just don't see a dimension anywhere. Is there any other sixes? Okay, well, in any case, it's it might be this MXL thing. I don't know what MXL MXL is just M by length. Yeah, I'm stupid. But I still don't know what holes that's like. Oh, 4 by MXL. Okay, cool. Got it. This is GN. It's an M3. It doesn't say its depth, but I'm gonna say it's 6. Anyway, so let's just sketch on here. So basically, the outline is going to be. Why don't we just give it? I don't know, 0.2 general offset clearance. This thing is actually not as well made as. There's an angle to this thing. I don't want to like pop it off of it, but it's there's definitely an angle. You can see a small gap. Whatever. I think it'll be fine for my pen plotter. Yeah, I saw this BPS space video, and he's like, what I'm optimizing for is not cost. It's not anything else. It's whether or not I give up. And you're really optimizing for just keep the velocity, keep the ball moving. Okay, so let's just define this. So what I'm going to do is it's going to be the shape looks like I guess it looks like this. And this I could just make a V because I think it could have a little radius on it. It could be like and then we'll do this, we'll delete that though. And then it's like that. right? So it goes in, then it goes up a little bit, then it goes over, and it, you know, does the same shit. And just to be cheeky, just to be a cheeky bastard. Oh, wait, that was, okay. So first off, I want this to be, how do we make sure that this is centered on here? Just make this a construction line, and then we'll just say that this and this are, how do you do it? Like, okay, there you go. And this needs to be moved out. Okay. And then these are equal. Did that work or no? There you go. Okay, so so the distance between here is going to be so let's just say carriage clearance. And we're just gonna say that's 0.2. So then this is going to be shoot. What is it called? I need the picture. WR plus 2 times carriage clearance. Okay, great. So now what does that mean? That's 15.4. So then in here, the distance between here should be, well, let's make it all parameterized. Let's not use 11. So what this is going to be is this is going to be WR minus 2 times not the notch straight, notch inner to rail, yeah. Notch inner to rail inner. Okay, then we need to just adjust this to be plus 2 times notch clear or clearance. Okay, great. And then we want this all to be equal. Okay, and then what we want to do is we want to take these two and delete them and then make just the tiniest little arc. You know what? I'm not even going to do the arc. But let's make, let's say they're equal to, and then the distance here, let's just make it 1. But then we need to make sure that the, so what this would be then is this distance to this distance would be 2.5. So this would be the 2.5. This is top to notch top. But it would be, oh, so let's make this like, because what is the, there's one missing here, right? So this, we don't want this to be 1, but we want it to be like, let's just say, where's the 10? HR minus top minus bot minus 2 times carriage clearance. That's 0.6. So then this distance is going to be top plus carriage clearance. Okay. But then this still needs to be 10, right? Wait. I'm thinking so dumb. This is not 10. This is where even is the dimension on that? Oh, we got n. I haven't used n yet. So n, so this is going to be n. So let's just get all what we have down. Let's get rid of this. So this is going to be n. Wow, that's big. Okay. Oh, H1. What is H1? So we actually, so like what I was going to do is I was going to do this to this is, so this is going to be, it's going to be top, it's going to be bot to notch bot But then do I add 0.2 or do I subtract 0.2? It's going to be, it's going to be plus 0.2 plus carriage clearance. But then we need to do a minus n, right? Why did that all fail? It's because something is greater than something else. So this needs to be minus n, right? Or not minus n, minus h1. So why? What? I mean, that's true, but why did all of this fail? Distance between here and here is 2.7. Whoa. Why is that? Oh, because I have this. Let's just remove this. Because that does have a dimension, but it doesn't mean what we think it means. What it means is, something random. It means something random. Oh, H? Wait, I think I'm using H in an incorrect way somewhere. What is H? H is 16. Dude, I need to build this feature where, okay, well, good thing this thing literally only has one real sketch in it. Okay, I don't think I am. I don't think I'm using H anywhere. Because this is not H, this is H minus H1, 12. Wow, 12 on the dot, man. That's good stuff. So we want to do this to this, and this is going to be, yeah, 12. And then let's just bring these. The thing about, okay, first off, these need to be equal. Okay, so at least now we have this. We can adjust this. But we should be able to adjust this too, right? Because this is not, that's not right. WR. No, this is W. Wait, where did I even get this? No, this is just straight W. Wait, no, but it's W. No, this isn't W. But we should, wait, no, this is the wrong dimension. That is fine. It's that, I don't know where this thing got a dimension. I don't think it should, right? I should be able to move this. Oh, no, this is a freaking vertical constraint onto that. That's not right. Okay, yeah, so, because this is just this bevel, man. It's just this tiny little bevel. So anyways, we're going to take this, and make it W. And, of course, something fails, but I don't know why. It's probably because of something stupid like... this. This is N. It should be N plus W. 2N plus WR is going to be... what is that? Oh, maybe we can derive the clearance because maybe my just judgment on the clearance. So that's going to be 17, right? So 17 plus WR. Oh, so we just need to make this 15. So if we make this 15, well, why don't we just remove it? If we remove this, wait, but there's still problems. Why is that? Oh, because of this. If I make this 11, do we think that, and then I make this, what's going on? And then I make this, what is it? N? Okay, so there we go. So I guess I resolved some of that. All right. So yeah, so the clearance, I don't know. It's clearly there, but I guess we're just gonna ignore it for the sketch. Then I don't know how I'm gonna do this bevel. Do it the old fucking fashioned way. Let's just say it's 2. So first we're gonna do 2. I don't see any. There's no way that they're gonna have a thing for that. Ooh, I didn't know what that. I don't even know what that is. And then I think that these are equal, right? Okay, cool. So then this, obviously a 135. Okay, so we got the outer profile done. This, okay, it's just the height. Wait, how did that happen? Oh, if I, oh wow, that's interesting. I guess, uh, let's see here. So it's gonna be H. So the distance between the top of the rail and the bottom of the carriage. So what is H1? H1 is 4. So if H1 is 4, then that means that this should be 6, right? So I'm pretty sure that this needs to be, yeah. Hopefully this works. But this needs to be the height, which is H or something. HR minus H1. Nice. Cool. And then this, I mean, who really cares? What did I set it to in the other part? Who really cares? Close enough, am I right? So I can't move this, but I can move these closer in. Dude, what keeps happening? What is happening? If I set this to 2, oh, interesting. Wait, did I actually do this right? Uh, yeah, I mean, that's right. Let's make it 2.5, right? Oh, Jesus. What the hell? Why don't we just leave it like that? I feel like that's fine. All right, so now let's get to the rest of it. So the so it's gonna be extruded by L. I'm a little worried about interference, so why don't we just start off with oh, we had an assembly, right? Okay, so this is gonna be insert. That's gonna be these two. And so how do we want to do this? I don't know how this works. So first off, we need to name these things. Hello? Go away. Oh my God. Okay. Okay, so we want to ground this. So fix this. And then, oh, okay. So this we want to mate. Yeah, that's pretty good, except it's not going to be fastened. It's going to be, is it planar, parallel, ball, slider. Definitely a slider. No, so that's the wrong way. Ooh, that's kind of cool. So let's just try this again. So, slider mate. I don't know how to do this correctly. Should we just look up a little video? Because the problem is if I put this on here and then I reorient it, even if I animate it, it's going to be sliding the wrong way. Let's look up slider mate.
Hi, I'm Nathan from FTC Team 4717, and welcome to the third episode of our Onshape Assemblies series. In today's episode, we will be going over how to use the slider mate. I'm going to add in my new, I'm going to go down to this plus button, and once again create a new assembly. Once this assembly loads, I'm going to go up to Insert, and I'm going to add in my new parts. But this time, I'm going to do it a little bit differently than I have in previous tutorials by going up here and clicking Other Documents. And you can see that it gives you a couple more options, including your linear bearing rail. So for this part, I have to add a length, which I'm going to set as 10, then I can press Enter, and click and drop this in just as usual. So the first thing that I'm going to do is right click and click Fix so that I can no longer move this around. Then we can go ahead and add our slider mate onto this rail. So I'm going to go up here to the slider mate, which is right next to the Revolute mate, which we covered in our previous tutorial. And once I click that, it'll allow me to add
this
mate
is a
connectors
good
just like all the other
video.
mates. So the way that the slider mate works is it'll constrain one of your pieces to move along the other one in only one direction. So this green piece is my slider, and I'm going to have it move along this rail, and it will move in this direction. And so I will be able to drag it in that direction, but I can't move it in any other way. So what I'm going to do to add this mate connector is I want this blue line right here, which is the z-axis of the mate connector, to be pointing in the direction that my slider will move. So I want it to be on this face. If I hover over this face, it'll go in the right direction. Then I'm going to move it up to this point right here. And
Oh, okay. All right, so that's it. Wait, what does he use for the other part, though?
Then I'm going to do the same thing on my green slider piece by hovering over.
Okay.
So now.
All right. Slider mate. Slider mate. Ugh. And it's, I think that's minus, I think I want it to be minus rail len plus L. Okay, let's play it. Why doesn't it play it slower? Jesus. Play slower. Alright, I think that's right though. Alright, cool. So that's what's up. I do want to change the appearance of this. But so there we go. Alright, so now we just have to add the mounting holes. So H2. So just draw a sketch on here. Is it threaded? Surely it's threaded. We can test that out. And then we need to know its depth, right? I never checked its depth. Oh yeah, I did. It's like 6. It's not going in. It does say, it does point to it, right? GN M3. Maybe these aren't M3. I think those are M3 though. Why am I even modeling this? I'm not. I'm not. I'm not going to model this part. Okay, I don't need to model that. I mean, I'm going to put it in, but I'm not going to model the threads. Because, like, I couldn't get them in. Alright, so there we go. There we go. Oh, wait, let's, mirror, plane, plane, mid plane. That's what I meant to say. Okay. Take this, extrude it, remove, and then let's just say 6. Okay, mirror, feature mirror, features to mirror this extrusion, mirror plane, this plane, this plane. What the hell? Cool. Okay, now we can do this. This should be relatively easy, right? There's no top view though. Oh, we don't need a top view. Okay, so it's B and B1. So let's just do this. Circle here to here, B1. Okay, what is the dimension of the hole? There's a thing that points to it. 4 by MXL. So we're gonna say this is a MXL. Okay. And then from the other side is it's gonna be L. Wait. L minus C over 2, right? So L 42.1 minus C. L minus C. Wait. L minus C divided by 2. Is that? I guess that's right. There is a little notch there, but I say we ignore that. We just make it flat. Okay, great. But that doesn't look right. Does it look right? Looks a little... I think it's because what we want to do is we want to say, okay, but then we want to go to not that sketch, but this sketch. And we want to make this be like 1. That looks a little bit closer to what it actually is. Okay, then we're gonna, are we gonna circular pattern it, or are we gonna mirror? We could just do 2 mirrors. I mean, it's the same shit. I guess the mirrors make the most sense. So this is defined. Mirror. It's gonna be this plane, and it's gonna be this. Okay, then I want to just get, I'm not done. I ain't done with you. This is 20 exactly, and C is 20, so that's good. So we just want that as a driven. Okay, then we want to mirror again, and we want the mirror line to be this plane, and then we want to mirror these. Great. Okay, now we want to take all 4 of these circles. Yeah, dude, when CAD gets really AI enhanced, it's gonna be so sick. It's gonna be so easy to. That's not what I want to do. I want to do a remove, and then the depth is 4. And then we do want to actually. They have an external thread, but they don't have an internal thread. It's so weird. It doesn't actually say what the pitch is. Why isn't it doing it? What the hell? Whatever, those are threaded. And we checked that the M3s go in, so, you know. Good stuff. So I think we're done, right? I think we did the rail. All right, so the assembly is done. Great, so I'm going to use this in another document. So I'm going to make this, let's see, document details. How do I make it public? Share. This document is private. Make public. Can view link. Yeah, no can link sharing. Okay. Great. So I mean, because how else do I get the... Okay, so I should be able to, I don't know how I do this, but I'll try to put the description, you know, this in the description. I'll just put it in chat, actually. Okay. Great. So we're going to make a new document, and then we are going to build supports for this so that holds this up. And then I want to watch this video again because... Right. I want to have a belt with a limit switch by tonight really badly.
Hello, I'm Lewis, and welcome to DIY Machine.
See, that's a great design. Look how close his are together, by the way. Okay, so we'll take this as inspiration, I guess. I think, okay, so there's a number of constraints, though, in that we can't... Let's see. By the way, these pulley wheels I got are too thick, man. I think I might need to get another belt if I don't want this to slide back and forth. Fuck, I think I got it. Well, we'll need to check. I think it'll be fine for what we're doing, I guess. Something will hold it along the axis. So let's just get started then. So we're going to use this. We're going to keep the carriage there. And then we're going to put 2 parts at the end that hold this. And then the nice thing...
Where in today's episode, I'll show you how you can build your own, mostly 3D printable CNC drawing machine. This project has a relatively low cost and can be used to draw on as many different surfaces as you can think of.
Dude, this thing is so
You can make
awesome.
letters, drawings, coloring in templates, invitations, and phone cases.
Dude, the thing where he
just to name
prints
a
on
few.
icing is so weird.
Have a look. You can change the pen's each thanks to the thumb screws during the print itself.
Is that like, hopefully that's a special type of...
Swap them for some edible ink, and you can draw onto a sheet of icing. And you'll find these to be done. Chromed power so linear move arches.
I don't have the linear bearings, but I have pretty much everything here. I don't have some of this hardware, actually. M5 by 25. I have an M5 by 20. So we'll see. Right, we need a... Oh, actually... Yeah, the other end is not the same part. The other end is simpler. Okay.
To over tighten the nut and risk deforming the 3D printed part. We only need to hold the bolt in place. Now attach our linear rail between the two supports for the X-axis.
Okay, so... Okay, yeah.
Left edge of the idle end should run up to the edge of the board and at least 28 centimeters from the front edge. The powered end can also then be fixed to the board. The raft mount can then be positioned over the linear sliding block and is secured to it using three M3x10 bolts through these
Yeah,
holes.
so what I'm thinking to start out with, because, you know, it's so hard to like get over ambitious on these projects because then you end up just dejected, is so let's just build the two ends of it, and then we want the simplest carriage that's going to trigger I guess the carriage could have the limits. The carriage, well, I don't know. Ideally, as little as possible is on the carriage, I
Use
feel
four
like.
M3x6 bolts to attach the stepper motor. You want to ensure that the wires are exiting away from the drawing area. The timing pulley can then be added to the shaft of the stepper motor, but don't tighten it up just yet. We can now take our 80 cm length of timing belt and attach it to the raft that slides side to side. To do this, take one end of the belt and loop it back round on itself. You can then push this loop that you just made in and around the column at the bottom of the raft.
Right, so that's kind of the... Okay, so... Okay, so we're going to make like a C-shaped part that we print like this. So the C is like this, and we print like this. And it's just going to have just that. But the important part is... It needs to be... Okay, so the belt doubled up is 2 mils about. So we probably want it to be... Then let's... Oh yeah, this stuff is pretty hard, so I don't think I'll have a problem with that. Yeah, so we want it to be like 2.2 or something. Okay, so let's just get started, man. I'm hyped. I'm ready. Okay, so this is going to be tinycnc. This is gonna be the project, bro. So, oh wait, but I want to import the variable studio. All right, sick. Cool. Very good. Very good. Very good. Very, very good. Okay. So let's start with the assembly, and we're gonna insert I feel like we just do this. Okay, so we'll get a hang for this. So let's do the easier end first, just to get a hang for it, a thing for it. So um okay. So let's take one of these. I wonder if I can get a part for I wonder if I can get a CAD model for this. I'm almost positive I can. So let's go to McMaster. These things are like absurdly light. I feel like they might even be hollow. It's kind of crazy. The thing is, I don't know. I don't remember. Okay, GT2 pulleys. Yeah, it's like this. With hub. I think, let's see, let's do an inner diameter measurement. It says 7. So so it actually, okay, so then this is, can we just find the part? Fuck, I didn't push my code where I had all my parts. Let me just go on Amazon. Well, let me just go on Amazon. Definitely this. 20 teeth. Number of teeth, pitch. Yeah, inside 7.3. Yeah, that's literally, yeah, that's basically it. Outside. Okay. I mean, it's this. It's clearly this. Hub diameter. Let's just make sure the hub diameter is right. 17.4. Is that what? See, that's not right. This is 16. Oh, here's the drawing. Why am I so stupid? All right, so I guess I gotta CAD this thing out. Yeah. All right, so let's just do that. And I'm actually gonna put the okay. So, how do we want to do this? Is the best way to do this a revolution? Kind of a tough part, actually. Yeah, so I think I think what you do is you draw half of this. So let's get the. Okay, so we're gonna do. Let's just do this. You like this. And you can actually go like this. Okay, and then just do this. 7, 16. Oh, there's a bore. We need to do the bore. 7.1. So is that locked in then? 7.17 is 8. I thought I just said, oh, but then this. So what is that? Oh, this is 12.22. So this is going to be, and then what is this? Oh, this. All right, cool. So now we can cool. Let me just do this, 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 this. Yep. Right. Oh, shift. Yeah. Okay. Remove up to next. Okay. Great. And do we want to go the extra mile and learn the GT2 geometry? I kind of don't think so. I feel like this is good enough for me. Okay. What else do I need to do? So, let's just freaking think about it. Oh, what is that thing called? TL draw. I wish I had a new tab. Yeah, can I just get a new page? Dude, get rid of the fucking Christmas stuff. Are you joking? That is the most obnoxious thing I've ever heard. Alright, I don't care. I don't actually care. Okay. So, yeah, but that's so annoying. I just wish Paint had a dark mode. Paint is so bad. So, so this is the stepper. Okay. Then this is the thing. So this is the pull. This is the actual belt. Okay. So then that means that the belt has a there's an inequality here where the belt has, or sorry, not the belt, the rail needs to be above this, and this is going to be let's see, the diameter there is 6, so it's going to be like, let's just say this is h over 2 plus 12.1212 or 22 over 2 plus belt thickness. So that is the top. So that is that. Okay. So let's figure this thing out then. So it's literally going to be okay. So this is going to be oh, I know this freaking spacing by heart, but I don't have any of my variables on me. So we need to go to pan tilt, I guess. So we need to go here. We need to look at Because the thing is, I think that my okay, so stepper shaft height. See, I wish I could just import everything with the name stepper onto it. That's why I actually should have multiple variable studios, I guess. It makes sense that everything was I wonder if I can just you can't copy anything. That's so they make it so difficult, man. All right, why don't we just copy what we need? So the notch height. The notch height? What is... Oh, wait, no. The notch height. Okay. Shaft height. Notch clearance. What does that mean? Oh, that's just a clearance. Okay. Stepper shaft diameter. That makes sense. Stepper shaft gear clearance. Yeah, okay. Where's stepper W? Stepper width? Okay. Okay, so in every project you end up having to do this. It's so annoying. So why don't I make a new variable studio? Great. Oh, okay, but that's from another one, so that's great. Just give me stepper W. Be like this. So, well, why don't we insert? Let's see. So here's what we want to do. We just want to make a rectangle. So if you make it stepper W by stepper W, that should be fine. Okay, then I forget. I'm pretty sure that the way this goes is it goes like. Let's just double check. Yeah. Just copy this in here. It's such a long name, but it's like. Then at least it's parametric. Or it's, you know. So. Okay. Then what did we say this was? This is an M3. So let's just make it. Oh wait, but stepper mounting hole. Shaft hole. That's shaft hole. I think we just use M. Let me get a stepper motor. Okay, so we got a stepper motor here. What am I doing here? This doesn't actually tell me anything though. Well, I just want to know if it's an M3. Okay, so it's an M3, so it should just be M3 hole then, which I think is 3.4. So just make that 3.4. Okay, so let's just do that. So make a variable M3 hole. And this actually will go for a lot of stuff. So that's, oops. Okay. Okay, so now we're on to my own design stuff, so I don't really have to worry too much more about the other tab. Okay, so this is going to be M3 hole. Okay, so what are we doing here? We're making just a cutout of the thing. So this is going to include the notch, right? So the notch hole, so stepper notch hole or something. Stepper notch diam is 22. So stepper notch. Let's just look for a 23. Stepper notch hole. I got the best names, bro. I got the names. You ever look to me for a name? I got it. Because that makes sense. So it's going to, whatever. It's really not that important. All right. So what do we want to do here? We want to, yes, around that, but I believe that's right. So then all we have to do is we'll make this like 5. Well, we don't even need to make that 5. There's no reason to make that 5. Wait, why is this under... Oh, because it doesn't automatically apply the coincident constraint. Okay, there you go. So then we have this extrude, and this is going to be 3. Okay. So the idea here is that this is going to be a little big, right? But that's okay. But so the stepper motor is going to be resting on the ground with everything, which is good. I feel like that's fine. And then kind of what we want is to just extrude this by like 5 or 3. I'm going to do this. I don't know. 3 is going to be just some random number. Let's just make this 50. And we just need to cut a big ass hole. Wait, 50 is too long. Honestly, prototyping, like it's like you gotta go quick. So let's just make it, I don't know, 30. Well, if we think about it, so let's start to put an assembly together. So we also want to insert a stepper motor, which is in here. Let's see if we can search. Insert other documents, back, pan tilt, step. Great. So maybe we'll make another assembly. Okay. Okay, we got this. Current document. Motor mount. Okay, so then let's see, we're gonna mount. It's gonna be the center of this is gonna be flush to here. But then we want to flip it around. Okay, great. So yeah, so since this sticks out by 23, or I think it should be exactly 24. No, 21, that's right. Wait, 21 with a wall thickness. We want to, Yeah, 22. Right. Okay, check this out. So then what we want to do is we want to actually attach the GT2 pulley wheel. So it's gonna be this. Okay, and then what we want to do, let's just the thing is, let's see, it came with the tiniest little Allen key, so let's use that. Slide this on here. So even if this is flush with the top, are we gonna get the flat? I don't know if we get the flat because the height of this is 16, but the height from, oops, let's undo this. The height from here to here is 15. So I think you need to be a little bit above. But you could also just flip it around. Like, it doesn't even matter. Like, that's arguably the best. I don't see anything wrong with this. Where you have the top. Because then you're guaranteed to get the thing, and plus you're closer. So, okay, so we're going to just flip it around. Because then it doesn't matter. And we have a good fasten. So we're going to make this to here. So now the calculus is going to be, let's see, I guess we want to know from this date, from this feature out. So from here to here is 21. So 21 minus 7.1 or something like that. Wait, can't we just measure it? Why am I being so stupid? Alright, so it's like 6.9. Tee. Tee. Okay, so let's just get on here. We're just gonna cut out a window for it, right? So it's literally, it's not that complicated. We want it to be, we kind of want it to be as small as possible, right? Like, so, oops. All right, so how does this go? This is going to be, let's make this 6. Okay, let's make this 10. Let's make this I don't know what we want to do there. This just needs to be the diameter here is 12. So let's make it 16 or so. And then we kind of want a line up. Okay, like this. This is a Q. This and this are midpoint. Midpoint requires a point and a line. There we go. Okay. Okay, so now let's take a look at the, oops, let's take a look at the assembly. So this is going to be renamed as the Motorx. Okay, so it kind of looks a little small. So we're just going to make that height a little bit more. Just make it 20. And let's make this like 12. But I think that looks good. Right, like if we go normal to this. It's not going to hit, right? Maybe we could decrease the, make it a little bit more symmetrical. What am I doing here? So this sketch. So what did we say? This distance was 6. Let's make it 5. All right. I mean, that looks good. I mean, I don't see there being a problem here of it rubbing or anything like that because the distance between this lowest point should be, yeah. So we're good. So we could print this part, but what we need now is we need a little top to it. Right? So now we need a top. And I don't know if this is stupid, but what I'm thinking is, because what did our drawing say? Our drawing said that the rail just needs to be above that top of the belt. Because the only, and the reason for that is that the carriage mount has to connect to it somehow. I guess it could be above it, but maybe that's not the best way. Okay, so then let's just do it. Let's just do it. So what I'm going to do is sketch this. Oh, wait. Okay, so I'm going to take... Oh, wait, I don't know what the... Okay, that looks good. So we're just going to take this and this. Okay, so I'm just going to cheat a little bit. Let's go back to his... I like his that it has an inset. So why don't we do that? So we'll have it go... So we kind of want to maximize the... Wait, we want to make this, though. Maybe more like 10. No, not 10. That's crazy. Maybe like 6. Because then... Okay, so it's drawn here. So we need to make sure that this is exactly lined up. So the belt should be... Let's just for the sake of having a reference, the belt is going to be on the thin part. It's going to be closest to the stepper motor. So when we look at this assembly, it's going to be on touching this face. So the distance between here and here is a very important thing, and it's 69. 6.9. So we're going to go here, here, this, 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 this. What just happened? 6.9. Do we... Wait. Does the rail actually need to be above? The rail doesn't technically need to be above. In his, the rail is not. In his, the rail is way far this way. It's like, wait, can we make this? This needs to be... Do we have all of our... I don't even remember the stupid, oh. WR. Oh my goodness. We want this to be like 22, 25. Oh, right. We need it to be 6 for the threaded insert. That's what we need. So then we need so we're gonna... Oh, okay. So maybe we do want to make this like... 8. So then this sketch, we can indent down, remove, and we'll just remove like 2. We honestly could even do less than that. Because the carriage and the carriage mount will hit this. Here on this face. So there's no possibility that it. But what we want to do is we want to go like this. And we want to draw what the? Wait, what happened? Oh, I sketch on here. Wait, I think this is like a Q or something. Oh, no. What is it? Coincident? What's an I? Incident. Okay, but this can be dragged anywhere. So then the distance between here and here needs to be, what is it? E. Right, that's, yeah. And then this needs to be, so that's an M3, right? So, what is that? Little d is 3.5. So M3, so threaded insert for M3. Where are all my threaded inserts? Oh, here they are. I've really been meaning to just build a library out, but it's like so... Okay, so we have M3 inserts for... by 6. So this is going to be 4.8. And the hole is going to go down. Remove. There's a 4, but I'd prefer a 6. That should go like right. So what's the distance between here and here? Oh, okay, we have 2 left. Cool, so we'll put a threaded insert in there. Okay, so this part is done, right? If we look at this, we don't really need a notch in there to hold that. That's plenty. Strength-wise, I guess I'm a little concerned. What forces are really acting on this thing? We kind of want... Do we want to worry about physics right now? I feel like I don't really care about physics right now. If it's broke, then we'll fix it. Okay, so let's get the other side then. The other side is something that I do want to... The idle pulley. Okay, here we go.
The wood screws, we can then fix the printed parts to our wooden board. The left edge of the idle end should run up to the edge of the board and at least 28 centimeters from the front edge. The powered end can also then be fixed to the board. The raft mount can then
right, we don't have any mounting holes. So
it's sliding.
I want to look at that part. How is that part held in place?
Block and is secured to it using 3 M3x10 bolts through these holes. Use 4 M3x6 bolts to attach the stepper motor. You'll want to ensure that the wires are exiting away from the drawing area. The timing pulley can then be added to the shaft with the step length of timing belt. Tape you just made.
This video is so good.
Then around the tooth pulley, the belt over the idler.
Wait, where does he talk about?
Underneath it, and then around the tooth pulley attach to the step. Once printed, we can first add the idle pulley to the idle end. This is achieved by threading one of the M5.
So that was kind of the crucial cross section right there. Is like
threading one of the M5 bolts through this opening, then through the
I knew Palman hearted. You guys are probably gone. Had to eat some food. That doesn't seem so bad. I love his designs are so good, man. I'm not gonna design anything near that nice. Let's see. If I was gonna design it, so it's got to be the same height as this thing. Let's just do an offset plane. Okay. So if we're gonna sketch on here, so we want this to be the exact how do we want to do this thing? Um maybe I do want feet on it to put a weight down on it. Because um I don't have a good place to put it down on, but see how his is up? What a beautiful design. Kind of complicated, but you know. So wait, so this goes down. Wait, what? Right, yeah, this is stupid. Wait, but now I want to do this. Yeah. Okay, fuck it. Where's this plane at? Oh, wait. Okay.
Using the wood screws,
Let me get some paper, actually. Where did I put my notebook? I don't know where it is. Wait, so I want to actually. I want to do this. That's not right. Okay. Let's just do this. Yeah, I think we have to do 10. Wait, what? Why am I doing this? Ah, what just happened? Okay. Oh. Well, let's just do this. Okay, including. We could actually extrude. And then we'll just sketch on here. Let's just come up with something. Uh, whoa, 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 whoa. I don't know what to put here. Let's just do M3 hole. Okay. So at least there's some mounting holes. Uh, Excitler. Excitler. So I would like to do something like this. So let's just freaking spitball, bruh. Brother, let's spitball. My brother, let's spitball. So we're gonna go like this, this, this. Oh wait. Okay. Wait. Sure. Do we need it to be this big? No, I'm gonna go get a notebook. This is hard for me to visualize. Can we look at that again?
We can then fix the printed parts to our wooden board.
Where did he get the zip ties?
Using the wood screws, we can then fix the bolt and nut at both ends.
Oh, I guess
to hold
that's
it
just
firmly.
their stop.
Using the wood screws, we can then fix the printed parts to our wooden board. The left edge of the idle end should run up to the edge of the board and at least 28 centimeters from the front edge.
Did he already do the
The powered end can also then be fixed. But first add the idle pulley to
Okay, this is good. What's wrong here? 60? 35 plus 15 is 50. This is 60. All right, that's fine. Let's just let's just extrude this by 3. Then we'll put some circles here. Here. We'll make them all equal. See, I wish I could just chat with it. Just do 10. Oh, yeah. It's just so many button clicks. That's fine. Is it all good though? What's left to do? Oh. Okay. So then the shaft is in M5, so let's see. We kind of have a limitation here. Will an M5 actually go through it? Yeah, okay. Great. But huh. Uh, I think I'm gonna go scavenge for metric or non-metric then, because we do kind of need it to be slightly longer, and we also want it to, we want it to be an M5 though. I wonder if we can make it work. These are all just M3 sets. Ugh. Wait, actually, hold on. M5 by 30, M5 by 25. Nice. Okay, so I'm actually good. Bro, see, I got everything. I got it all. Okay, so that's what we're gonna use. We're gonna use the same as him. Oh wait, hold on. I don't want to make a mess here. Ba-da-dum, ba-dum, ba-ra-ba-dee-da-la-da-dee-dum. I'm so excited about this. Dude, this was such a good purchase. This was like 50 bucks, but it was such a good purchase. To get some nice long bolts. Unfortunately, they're hex head, which kind of sucks. But it's fine. I wonder if he posted the CAD. No, I'm not going to cheat. I'm not going to cheat. We don't do that here. I wish the bags were labeled. Okay. M5 by 25. So what we need to do is let's just freaking start messing around here. Sketch here. We're just going to make, let's see, the distance between here and here is what exactly? What? Why can't I measure it? What if I just click on the lines? 15. So we want a, oh, wait. We kind of want to do this. So it's actually made like 18. Okay, so, or wait, 18, we want it 16 plus 6, maybe? Okay, 22. So, I'm going to do G, actually, geez, why am I having such a hard time with this? Okay, so we're gonna just extrude this up. See, okay, so yeah, so that's not gonna work. But now, if we take this and make this 16, and then we redo it, the distance between here and here is 16. So we actually want to make it, let's make it like 16.2. We want it to be tight, but wait, that's the outer distance. No. Yeah, so we need this. Okay, so we want to undo this. This does need to be 16. 22. So then this is 16. But then these walls are too thick because 22. Well, we could just put a 30 on it. Let's just put a 30 on it. Okay, so then we just need to figure out where to put the hole. So the hole height is going to be stepper width over 2, right? So let's just freaking do that. So first off, la da dee da da dee da la da dee da 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 da. Wait, what? I did this. Okay, then this is going to be M5 hole, 5.4. Wow, that's a big ass hole. And then what's wrong here? Oh. Oh, right. What am I talking about, bro? So then from can't get that. How do I get the bottom? So that needs to be stepper width over 2. I'm almost positive of it. And this needs to be remove up to face this face. And then what's the distance between here? It's exactly 16, which is not what we want, really. We want to go back to this sketch, make this 22.2. There's a tiny bit of room in there. And the distance between here will be 22.2. And then we'll just figure out what bolt to use. And let's just make sure that this, because I want to know the center dist to here. This will give me the min dist. So this plus 2 is 8, but this is 16 in diameter, 8. So we want to, let's just make this like slightly, just make this, yeah, we want to make this like 18 or so. Just give it a little bit extra. So then it has some room. And then this thing is like way too long. This could be like 20. That should be it, right? His is so fancy. Oh, because of the rail. Dumbass. Okay, what is the rail height at? I'm a fucking dumbass. Oh. I'm a dumbass. Okay. So the bottom of the rail to the floor is this. It's 48.32. 48.32. So wait, but let's just get this height. So we're going to go to this height and we're going to just reflect that feature over. 50.32. I'm going to copy this. So let's go to X idler. And then when we go to this extrude, this is going to be 50.32. Wait, actually, can we do this -3? Oh, wait, but we need this. Oh, okay, hold on. I'm a silly guy. So we want this to be -8, right? Because then we are going to take this sketch, click on this and this, this and this, extrude it by 8. Okay, and then we are going to outline the track here. Oh, so we're gonna have to make this longer. Well, we could, we do want to stop, kind of. So So this goes to there. And we kind of want 3 on the back. So what we're going to do is we're going to go back to this sketch. And this, what did we make it? We made it 20. Yeah, a bunch of bullshit. You can see how bad of a catter I really am. Alright, so it's 22. So let's make it 25. And then as for this hole, we don't need to do this, really. We can make this closer. Because the closer we make it, we can just make it a... Makes it easier, right? But we want it to be a little bit more than that. Maybe we would 10. Okay, then we have this. So now we want this. This is 22. Okay. Let's get the circle in there. Let's make sure that this... What? Point and line. There we go, midpoint. Okay, this, do we have a dimension on this? This needs to be 15.2, right? Wait, but do we have a, did we... WR. Okay. This point and this point are H. This is a... Oh yeah, this is a, okay, but this is a 4.8. And then we need to know that this point to this point is 15. Perfect. Great. Now we can take this and this, drop it by 2, right? Wait, oops. Remove. But I'm pretty sure... Willis, what the hell are you talking about? Okay, so wait, we need to make sure that this to here... See, that's not right. Because that's supposed to be... That's supposed to be, 48.32, which is... So we need it to be down by 3. So when we did... And we need to be down by 3. So let's just... We do... What was it? Which extrusion was it? Was it this? Was it this? No, it was this. -8. -3. Oh. Okay, now. 48.32. And now we're ready to redraw this circle. I kind of don't like that it doesn't bottom out a little bit. Like the other one is also a blind, it's like a through hole, not a blind hole. And I don't like it. But in any case, let's just put the assembly together. Where's the other assembly? So we got this. Okay. Then we want to insert another assembly. Okay, like this. But we want to actually... I'm going to take this and remove it. And we have this. So, okay, so it went away. Then what we want to do is move this thing, mate this to here. Why does everything move? Because we never fixed this part. Okay. Right. Okay, well, we don't really need... Actually... Maybe when you want to extrude it more, because look at that. See how it would fall off of the thing? We could either put a stop here, or we could just... Huh. Alright, I think I'm going to just add a thing here. So we just need to go to X motor mount. You go here. We're just going to sketch on here. Is that going to work? Is it not going to update, dude? What the hell? Oh, there we go. Okay, so then it's coming. Boom. Where did it go? So there's no way to leave the track. Okay. Works for me. But I'm thinking, I mean, I'm adding that there, but I'm thinking that anyways, it doesn't really matter. I hate that. Okay. Something looks like an interference, but oh, actually, yeah, I messed up something, but it's all right. Okay, so let's just get the other part in. So insert Xidler. Oops, why did I do that? Xidler. Okay, so now we want to mate this to there. Alright, looks pretty good. The only problem is, dude, I wish we would get rid of these mates. Because this thing is no reason to not fly off the handle. So we just need to add the wall there. And then we're ready to print it, right? We need to design the next part, but we can print this and then wait and then design the next part. Because, dude, this thing is sick. This thing is sick. You can just build whatever you want, bro. This thing is so sick. Wait, is this the right? What? Hello? All right. Cool. I don't know. Honestly, why do we even need this? I think I'm just going to kind of mess this all up. I kind of just don't even want this part. Such a hack, dude. Huh. I just love building garbage at right angles. Nothing in nature is right angles, bro. It's all curves, but our tooling and our minds constrict us. let's look at motor X assembly. How did it do? Oh, never mind. All right. So we shall see. Okay, so we need to print out some parts. We got to print out, I think it's just these two, or not these two, these two. So let's rename those. It's going to be renamed. And I'm sure there's bugs that I have not noticed. And then, so we got the motor mount, then we got this part. And I wonder if I can rename this from here. Switch to rename. Seidler. Seidler. Okay, so let's export. Okay. We shall see. We shall see. No support? No way. Wondering about the holes, but you know, it might be okay. In an hour. Alright, let's do it. I'm gonna go look at it, I think, really quickly.
Hi everyone. I'm going to talk about a problem in number theory related to Artin's primitive root code section that I submitted for the benchmark. To state the problem, I need to introduce a little bit of notation. So, first we let Vp of n denote the exponent of b in the prime factorization of n. And second, we let odd p of a denote the multiplicative order of a modulo b.
Bro, what the hell? Wait, for a positive integer n, let VP of n denote the largest integer. Okay. So, what's an example? Right. There's like a recursive thing in here. What the hell? Oh, we didn't put in a thing for the limit switch. Let's watch the video. I can't read this, dude. This is too advanced for me.
The idler end. This is achieved by threading one of the M5 bolts through this opening, then through the idler, and finally tightening the nut at the other end. Be careful not to over tighten the nut and risk deforming the 3D printed part. We only need to hold the bolt in place. Now attach our linear rail between the two supports for the x-axis using an M3x12 bolt and nut at both ends to hold it firmly. Using the wood screws, we can then fix the printed parts to our wooden board. The left edge of the idle end should run up to the edge of the board and at least 28 centimeters from the front edge. The powered end can also then be fixed to the board. The raft mount can then be positioned over the linear sliding block and is secured to it using 3 M3x10 bolts through these holes.
Wait, what are we looking for?
Use 4 M3x6 bolts to attach the stepper motor. You want to ensure that the wires are exiting away from the drawing area. The timing pulley can then be added to the shaft of the stepper motor, but don't tighten it up just yet. We can now take our 80 cm length of timing belt and attach it to the raft that slides side to side. To do this, take one end of the belt and loop it back round on itself. You can then push this loop that you just made in and around the column at the bottom of the raft. The two teeth sides of the belt will lock together in the narrowest section. You can give the belt a gentle tug to check that it is correctly held. Now pass the belt over the idler, back around underneath it, and then around the tooth pulley attached to the stepper, and back again to the other side of the raft.
What a good video.
Repeat the same steps to fit this end in, but this time you'll need to keep the belt under tension when you insert it. You can now rotate the stepper pulley by hand slightly back and forth to check that the raft responds instantly without hesitation. If you notice that when you turn your stepper motor by hand, you can turn it a bit before the raft moves backwards and forwards, then your belt is probably too loose, and you should go back and tighten it before carrying on. You can now slide the powered pulley along the shaft of the stepper motor so that it aligns comfortably with the belt's position. Firmly tighten the grub screws, ensuring that one of them tightens against the flat face of the shaft. We'll start to fit some more components onto our raft now. Start by securing the idler by placing it in line between these two holes and securing it in place by feeding an M3 by 18 bolt through it. The second motor is presented from underneath the raft with its wire facing out towards this small arm. Secure it in place using 3 M3 by 10 bolts. Now add the timing pulley on top and secure it to the shaft so that it sits flush with the tip. Slide the 2 long linear bearings into the housing. Depending on how tight your print is, it may need a firm push to fit, or if you find that they're too loose, you can use 4 zip ties through these holes to help hold it secure like so. We now need to solder a few wires. There's very little soldering required in this project, and the first part will be connecting some wires to our 2 contact switches. Solder some 55cm long wires onto the normally open and common connections of your first contact switch. If you're not sure which pins these are on your contact switch, then you can easily check it with a multimeter. Set it to continuity test, attach it to the legs of the switch, then check that the circuit is complete when the switch is pressed, but broken when unpressed. Thread the wires through the channel here, and then use some glue to position the switch at the end of its recess. Make sure that the glue does not interfere with the operation of the switch.
Where's that going to
wires
hit?
to the same normally open and common connections of the second switch. This one can then be attached underneath the paddle against this protrusion so that it closes where the raft meets the idle end of the x-axis.
Idle end.
The wire can be routed around the stepper motor and then over this arm. Slide the wire from the stepper motor over the arm as well.
Oh wow, he put a
Keep the
lot
wires
of
together
features
and
into
tidy.
that.
You can use a few wraps of insulation tape spaced out along their length. Now we'll start to work on the y-axis of our machine. This is the one which push and pulls the pen forward and backwards. For this, we'll need 3 more 3D printed parts. This will be the servo end, the pen end, and the pen holder itself. Start by inserting an M3 nut to these 2 holes in the servo end, followed by partially inserting 2 M3/6 bolts. The 2 long rods can then be inserted and secured to the print by tightening the bolts. The other ends of the 2 rods can then be carefully inserted to the 2 linear bearings we have already added to the assembly. Take some care when you install the
So
rods.
I don't understand why you would why not just put the limit switches on the housing? Why put it on the carriage? Okay. So I think I'm going to try to put it I guess it's a cable thing. It's more so just for cable management than anything else. I kind of want... Okay, I think I'm going to do mine slightly differently. So we're going to build the carriage now. What the fuck? Wow. Dude, that's a tough problem, bro. Whoa. That's a tough problem, bro. Difficulty medium low. This is cool, man. Okay, so let's design the part. So we got this assembly, and this cart goes along and hits the edges. Bonk, 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 bonk. I guess, so what we're gonna do is we're gonna put a limit switch here. So what I think I'm gonna do is have it embedded somehow. Let's look at the limit switches themselves. It's got 2 holes. So I'm wondering if I put it right there. I could also put it like this. Let's see, that's only going to go to there, so that's not actually a problem. The only thing is, first off, these look like M2s. These things look real tiny. I don't even know if I have M2 threaded inserts. It's that small. No, I got M2s. Okay, so if that's the case, how do we want to organize this? Because we'll need to reprint this with, well, why don't we just put it on the carriage? I think that makes the most sense then. Dingus, dingus, dingus. Dingus, 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 dingus. Okay. So it's, so the first and most important part is definitely okay, so Excitler. I presume Excitler. So I kind of want to copy this. So we just want a plate that looks exactly like that. Okay, let's figure this thing out. See, it would be nice if I could sketch on this. Okay, let's do this. 5.228. I'm a little bit suspicious of that number, actually. Because it should be h minus h1. Wait, no. That's not right. Wait, h minus h1 is this. h1, this is 10. hr. 6. So this is 6. So this should be 12 minus 6. This should be 6. So this is too low. We messed this thing up. So our job is to get that number to be 6, right? Let me just double check that. Okay, so this distance is going to be h minus h1, which is 16 minus 4. This is 12, okay? Then we want to know the distance between this and h1, which is going to be hr minus h1. hr minus h1 is going to be 10 minus 4, which is 6. So 12 minus 6 is 6. Okay. So now we got to figure out how to fix that. And I wonder if it will update. We'll have to make a new version, I guess. So the problem should be so that's 6. So then there's just a problem with the assembly, I guess. Why don't we undo the slider mate? So this is 6. So if we mate with a slider mate this to that. Oh, wait. Okay, there we go. That looks way better. So wait, can we do a version? Create version. Fix the slider mate. Okay, so now what I'm wondering is, yes, that's so sick. There we go. That's exactly what we wanted. Awesome. And it actually looks not terrible. Definitely better than it did before. Okay, so now we have that. Okay. So it should be... So the rail is not quite on top of... So the rail to this, 3.1. I did do it 6.9, but I forget what that was. 5.4. Let's just start with a square or a rectangle like this. So it's going to be what is it? W, it's 32. I don't know why it's so frigged up. Why am I not getting my dimensions now? Okay, so that's 32. So that's good. Okay, let's see. What can we do here? So we need to, it literally just needs to be a C. I don't know why I'm tripping out so much. Let's just make another part. And this is going to be carriage. Alright, so it's going to be... So this is... Let's put this over here. Oh wait, don't we just have it? Okay, so what we want now is we want this to be W plus 3. Oh! Error! Error! I don't know how to do that! Stupid A. Stupid A. You stupid A. You stupid motherfucker. You stupid motherfucker. Okay, so we're gonna do this. Then we're gonna put the holes on. We might as well do that. Just do that. So, wait, let's, oops. Sketch, normal, C, this, circular. Is it circular? No, we're doing a mirror. So, mirror, select the mirror line, this, select the mirror again. This, didn't work. Mirror. Oh, wait, I guess it did. Okay. So now this is going to be 3 hole. Okay. Then this, the distance between these guys is going to be, C. And then the distance between this and this is going to be L minus C over 2. Great. Why not? Why? The hell? Oh, wait. Did I make it longer than it needed to be? 42.1? How did that even happen? Wait. But no, but that is L. What? Oh, wait. Oh, I lost my sketch. There you go. Okay. L minus C over 2. That should work. That's C. Oh, wait. For some reason that... Okay, I guess that's fine. And then this distance is B1. Really? Seems a little close to the edge there, pal. Wait. Wait. We can't mirror this second time. Let me delete these. Oh, wait, actually. So these need to be 6.5. I really wish it was easier to work with geometry. All right, well that should be fine. So that because all we want to do is well, first off, let's remove these. So let's take this, this, get down, remove, up to next, bam. We want to sketch on here. And I don't know how far this needs to go down, but let's just add this to the assembly so we can start to get a look at things. So we want to insert carriage. Okay. And we want to mate this motherfucker to this motherfucker. Awesome. And let's just okay, looks like we did that right. I don't know, do I want some leeway there? Okay, now we need to figure out how far over to go. Because what we're going to be doing here is we definitely need to come down way lower. I mean, the top of, let's see, the extrusion amount is going to be the top of there to the, let's just get everything global. Let me go get my, notebook so I can write stuff down. Well, actually, we know what it is. Okay, so what is it? It's that the bottom of this thing can't be, is it that over 2? Okay, so that plus, what is this, 6? So 27 high. And then if we do a minus, so the bottom of this thing is at 15 millimeters off of the ground. And this thing's at 27. Yeah, that checks out. So then the belt comes along here and hooks into this. So let's just get the general shape down and then we can fix all the dimensions once we have it. But basically, the extrusion, let's figure out what is the height of, so if we hide this part, what is the height of the top of the carriage to this? This is 64.32. Okay, so we want to go down to like 20. We want to go down to like 20. So that means that it's this minus 20. So that's how much we're going to extrude on the carriage. So this extrusion is going to be that. But it's actually going to be, well, let's just leave it at that. Okay. And then I don't know how far over we need to go, but basically what we're going to do is we're going to sketch on here, and it's going to be like, well, I guess first we're going to draw like a square to offset it. So it's like, oops, like something like, I don't know how we want to do this. I mean, I really don't. But if we just, We just extruded this by like 10. Okay, and then let me look at it. Let me hide this part. Wait, wasn't there a way to hide this thing? Is it V? What the hell? I could have sworn there was a hotkey for it. Wait, so that's 20, so it's 7 up. So wait, so... Yeah, 27. 37. What am I trying to say here? So let me actually calculate do the math of how far over I'm supposed to go. So from this to this is 16.7. So we want to go, yeah, out 10. I think that's perfect. So, okay, so let's go out that much. Let's copy this. Then we're going to go back to Xyler and extrude this by this much. But then what we're going to do is we are going to draw it's going to be like, and draw it like this. So this is going to be like 2.2. And this can be like 8. Maybe 12. And then then how do we want to do this? It's like an arc. I don't know how to do this. Because we need to let's look at the answer sheet. Let's cheat a little bit. Okay, so wait, let me start over. So we're gonna draw a circle and then another circle. This I guess can be 3. Who cares? And the distance between here, we want it to be like, I don't know, 1.5 or something. You know what the distance from here to be? Yeah, like 7 or something. I don't know if that's right. I actually forget. We'll find out. We'll find out. The purpose of today is just get something that like low-key works. Okay, now we're going to draw a line from here to here and another line from here to here. Okay, first off, we want these to be vertical. And we want this to be 2.2. Okay, then what is unconstrained about this? Okay, so then this can be like 12. Okay, so what we're going to do is we're going to take this. We are going to remove, and not that much, but like 7. And then what we want to do is we want to mirror those features. I wish I always do. So it's going to be this extrusion along this plane. No. What? All right. I mean, that's it. That is the part. Honestly, that low-key might work. Let's see. Is the print completely ruined? Why is it printing white? Really? I'm gonna go over there and look. I don't even know what that is. It looks like it might be my support material. Might need to refill and unfortunately reprint too. Okay, wait, but we wanted to add one more feature, which was okay, I kind of understand why he wanted to have the homing be on this side. So what I'm thinking is I might want to cat all this out. It's 20. Yeah, no. Wait, but we could put it on the back here. A little indent on the back. So it just like goes like this. Or maybe like this. Probably like this. Okay, so we're gonna cat out this switch. Actually, I want to know if maybe someone has already done this. Because this probably has an ID on it or something. I feel like this is so common that I might not have to cat it out. Well, let me go look at the print. Okay, so I am printing with support PLA, which is just fantastic. There we got the cobalt blue. Really? No knife? Bro, where's my knife? Yeah, well, that stinks. I don't know if I reprint it. I feel like I won't reprint it just for the time being. Just to get a sense of, we're gonna have to bust out the soldering iron, which means we gotta clean up a little bit because, uh, I'd like to get this set up. Let's see if we can get this set up. Is this on my PC? Is this plugged in? Okay. Alright, let's see if we can get this set up. It's gonna be ready to print soon. So I wonder if I can probably that's probably this. Nice. Okay. So we got the soldering iron set up, which is cool. Um Okay, so I'm gonna go replace this. I wish it would have told me though. Gonna be a long night. It'll be so sick when it's done. Okay, so what's next is I guess I need to print this. Let's see, I guess we need to add, how am I going to do this? I'm going to put threaded inserts in here, so just a couple of holes. It'll be like 2 millimeters deep or something, and then we'll attach this. So okay, so I guess I gotta cat out this switch. Let me just see if anyone has this, because I know that this model is probably, I mean, this is probably, just look up GrabCAD. Hey! I love it, dude. I love GrabCAD. It's so sweet. Look at that. Beautiful. All right, so then we're good. OBJ step. I feel like I'll just take the step file. Give me a sec. Oh, I don't even have it here. Dude, it's annoying they make you sign in. Okay. I'll just do this in Chrome really fast. Oh, wait, actually, wait, hold on. Nice. Dude, the sign in with Google thing is... Ugh. You gotta be joking. God. I was just praising it, too. Okay. We're good. Alright. Yeah, it's... Okay. So, this is the step file. It's so annoying, dude. Ugh. Microsoft is just... They're trying to dumb it down. They're just trying to dumb everything down because they're a bunch of freaking idiots. Factorio. Let's do this. Is I just the most advanced? I don't even know. Normally, dude, wow, what a beautiful part. They did it like so good. I mean, can you imagine if I had to do this? It'd suck. GrabCat's got everything. So we need to put that on here. So what I'm saying is literally we just so wait, let's just get the whole pattern. Lena Dunham. Lena Dunham. Whoa. Lena Dunham in the chat. What the fuck? That's not Lena Dunham. What the hell? Alright, so let's just make sure that we got the right part. This should be 20. Wait, what? Oh, wait, no. I think I got the 20. Nice. 10.2. Oh, I guess there's a notch in it. I guess there is a notch in it. You gotta wonder, like, if you really look at this thing, it's got so much geometry in it. I mean, you can see it here. This is a pretty accurate representation of it. But there's just so many random little things in it. And you're like, why did they do all this stuff? Why did they do all of this work? Okay. So we'll need to figure out the wiring, but for right now, I just want to. Okay, so then, so what I kind of want to do is align. I mean, how do we want to do this? We kind of want it to stick out as little as possible. What? Who the hell is Trinity Champion, dude? I know who Lena Dunham is. I don't know who Trinity Champion is, bruh. All right, so we're gonna take this switch. It doesn't really matter which side it goes on, but I guess I'll have it pointing down. And I guess we need that top lip to be the alignment datum. So we'll take, so it'll be flipped like this, and this part will line up with the other part. What is first time listener, long time hater? Thank you. That's fantastic. I love my haters. I love my haters. Jesus. Wait, but what is the radius on this? 2.5. Yeah, that checks out. Are you asking me? The hell are you asking me, bro? All right. I get no play. Thanks, bro. Means a lot. No matter what, it will contact it. So it's really, so maybe I'll just align it at the bottom. Okay, so what if we just try to insert it like randomly? Oh, but I don't want it to do that. Okay, so what we're gonna do is group them into one thing or something. I think you have to make an assembly for it. And we'll just name this switch. Okay. And then we insert this. But then I just want to group. Isn't there just a group? Okay, and I believe that now that I've done that, what I can do is just go into the assembly file, insert the actual assembly of limit switch, and then it doesn't show like all of that crap. Now, where did it go? So now the idea is we want to take like the we want to take like that and line it up to like on this face, line it up to like this, but then we want to wait, hold on. But I didn't do it right. Let me move it over there. So that face needs to go onto this face. There we go, like that. That's exactly what I want. So then the only thing that's missing is what? Dude, who the hell are you guys? Who let you in here? Okay, so that's good stuff. So now the only question is, what are those coordinates? If that is the case, then we want to know the offset from there. So let's go to this. And I guess, wait, am I stupid? Okay, so the min dist I guess we'll do the min dist. Okay, so it's 6.66. Yeah, what's up, Lena? So wait, so why don't we just do that? So it's over by 6.6. Well, no, it's not. It's over by 6.66. Wait, is that right? Ha, got him. 6.66 plus 1.25, right? 2 point. And then okay, so let's just start to get some of this down. So we're gonna go to the carriage. We're gonna sketch on here, we're gonna draw 2 circles. And we have plenty of space for this. This is good. It's gonna be like this, this. These are gonna be vertical. These are going to be equal. They're going to be, I guess we're gonna make them, we might as well make them 2.5. And then what's next is, what did I say? I said that this was gonna be 6.66. And then and let's see, they're gonna be, how deep are they gonna be? We need to know the spacing and then how deep they're gonna be. So the deepness, I guess I'll go, oh, M2.5, 4 deep. So they'll be 4 deep. And then let's figure out the spacing. So 9.5. Okay. I'm just gonna, well, let's test. Let's do a little test and see if that's true. That's the center dist, so it should be, yeah, that's right. So that's good. 7. So 9.5, and let's get to Roe v. Wade. I actually, you know what's crazy about that, Trinity Champion, is I have been looking into Roe v. Wade. I have been looking into Roe v. Wade because I've been looking at case.law, and I believe that if we do some graph theory, we can start to figure out just how impactful Roe v. Wade's overturn was. So I do have a plan for how to use my platform to impact the world. So that's coming, but not right now. But yes, I have been thinking about Roe v. Wade. Dipshit. Fuckwad. I have been thinking about Roe v. Wade. Threaded inserts are great. Maybe we can make this a little bit taller so that we have like a. No, the problem is it's hard to get them out of there. But they're 4 deep, and this is 3 deep, right? Oh no, yeah, that's 3 deep. So why don't we just so this extrusion, this sketch, this, let's just make this 20. Hopefully that doesn't, yeah, that didn't throw anything off, right? Because this sketch was all from the bottom corner. Okay, cool. Yeah, it's so interesting. After you do machining, you're like, man, you play around with datum, but if you were to actually, try to design something manufacturable, it's like, that's what's so great about 3D printing. It's like you don't even have to care. Oh, wait. Oh, yeah, I never measured that. So now we need to measure one last thing, which is the distance from here to here. And that's 4.25. Great. So, okay. Awesome. Now we could take this. Oh, wait. But this is going to have the threaded insert in them. And the threaded insert is 3.2. So we want to make them 3. So let's edit the sketch because we want this to be 3. Maybe even like 2.9. I don't know. I feel like that'll be fine. It's not like it's going to undergo a lot of force. All right, so now we can extrude this, remove 4. Bam. Okay, so now if we look at the assembly file, It does look like everything lines up, but not... Everything lines up almost. But it's like, not quite. It's like just barely off. I think what we... Should we just nudge it a little bit? Let's make it like 6 point. Did that do anything? It'll be fine. All right, cool. So we got the limit switch. All right, so that's it. We did it. So now we can print that. Oh, and the print is probably done, right? The thing is, I printed on freaking support structure material. So what we're gonna do is we're gonna go install a new roll, a PLA. Okay. So I'm using, so I used freaking support material because I'm dumb. But let's just see how this goes. We're going to try to put it together. So the idea is, I don't know if this is going to show on the camera. So you put this in like this. Okay. So what we're going to do is, first off, let's install the motor. So let's take this off. Get the motor on here. So we just need like really short M3s, right? So M3x8. Where did they go? There we go. M3x8 might not even be. God, I can already tell getting into this corner is gonna be I'm honestly only gonna do 2. Let's get up. Wait, where did all my Allen wrenches go? Uh-oh. What the hell? Okay, let's just build the rest and then I'll go get it. I lost all the Allen keys. That's terrible, man. All right, good enough for right now. Let's print the carriage because I feel like that's the most important thing that we can do. I mean, it'd be great to see this thing freaking work. And then what we'll do is we'll do an unboxing of this board, and I'll go find my Arduino Uno. Oh, beautiful, beautiful. Oh, we got a Nano in here. We got my trusty Uno. I think this might be a different one, but I got my trusty Uno. Dude, I love that I've organized this and I just have everything at my freaking disposal. I didn't even know that we had these Nanos. Having a couple of Nanos around is not the worst thing. Alright, let's see what we got. You know what's crazy? I got this thing on Amazon. Wow, it's smaller than I expected. And it came with 4 of these stepper drivers. I mean, these things are like candy, bro. They hand them out for Halloween. They're everywhere. So this is the CNC board as I understand it. It's a shield. So what you do is I mean, it must go like this. Okay. That's great, man. Oh yeah. And then dude, I'm so sick, bro. Cuz then I already have a 19-volt thing plugged in here from earlier. I got my maker set up. I get my maker set up. And I can make whatever I want in my desk. Okay. So the next thing is we need one of these, and then we need a M5 nut. I got my M5 nut. Hot damn, bro. I got my M5 nut on. Duh. Okay. Yeah, these 25s aren't gonna do it. My baby. My baby. My sweet, sweet baby. Okay. So we want the M5 by 30s. We only need one. There. I'm starting to get more efficient with making stuff too. So we want it to go. Ooh, it's a little tight. I think it might be okay, but it is a little tight in there. Okay, so you can see here that we have the idler. So this is for the idler. Damn, I mean, we're gonna be able to set this thing up like right now. It's kind of insane to think about. Literally, I had this idea. Well, I didn't even really have the idea. So we need, okay, so we need to put the threaded inserts into here, into here. Oh, so I kind of shouldn't have screwed this on. It's okay. So I'm just gonna switch over to this, and then we're gonna get the threaded inserts. And I believe I'm using an M3 by 6. Wait, let's just check the diameter of that really quickly. .8. All right. And that's that. Dude, I'm loving this, having this camera here. I gotta be careful, though. Okay. So, yeah, kind of fucked it, but, you know, it's whatever. Alright, so let's, Dude, where did all my Allen keys go? Someone is pranking me. Like, big time pranking me, dude. It's an M4. Ugh, okay. I'm gonna go look, just because I feel like I'm gonna freak out otherwise. And that's an M2. Dude, I've pulled a heinous prank on myself. Whatever. Alright, let's just get this installed. So, oh well, I guess we do need the Allen key to lock it in. Because we do kind of want it to be tight. Yeah. Alright. Got a Allen key thing. It's not. Dude, it's so weird. These Allen keys, whenever you see 3, it's not 3, it's like 2.5. I don't know, maybe it's like, I don't know. Very bizarre. Okay, so, alright, let's do this thing. Hopefully that didn't cause it. Oh, it obviously did. You gotta be joking. Okay, how am I gonna do this? I think I'm just gonna try to... I'm just gonna try to take a knife to it. So I burned a little bit. Maybe? Let's see. Alright, that seems good. I do kind of want to make that indent a little bit deeper, honestly. Alright, so let's get the other one in. Okay, we're going to take this out. And we're going to do an M3 by 8, I guess. Well, let's see. What is the... Oops. What the hell? Oops. Okay. The thing about it is... this whole thing is HR, which is 10, right? And then little h is 4.5. 10. So that means that this is... Alright, whatever. Let's just do it. I mean, it really doesn't matter. So it's basically whatever I have more of. This is all mixed up. Oh yeah, these are the 12s. Okay, I'll use the 12s. Okay, now here's the test. Is whether or not this thing... It doesn't come off of it, right? So that's good. We don't want to lose these little caps, though. So I don't know where to put those. Alright, so wait. Let me print the freaking character. Let me do this. Okay. Alright. So now we have a rail that has a motor connected to it, but nothing really, you know, to work with. So let's... Carriage. Already 10? What the hell? Yeah, so this is it. Man, this is it. This is that whole thing. Oh, do we want to actually counterbore? How deep are they? They're like MXL, right? So it's by 4 deep. So we'll put 8s in there. Huh. For right now, I just want to print this thing. Carriage. I don't even know if that's spelled right. Alright. I think it's carriage. Alright, so let's print it. And let's freaking refresh this so we don't have... There we go. It's 30 minutes. Threaded inserts low-key are a game changer, though. Hopefully that'll go fine. It's actually... Yeah, that'll go fine. And we did 2.2. I'm hoping that that will be enough. All right. Hell yeah. I could have made this easier to assemble on myself. I could have made this open backed. That would be nice. There's no reason not to. Strength? Like, are we kidding? Which one is it? It's Idler, right? Idler. Right here. I don't know why it printed like it was two parts. It's kind of a weird thing. So, I want to just take this, extrude it, remove up to neck. My computer kind of made a weird noise. I don't know what the heck that was. Dude, why does this... That's so funny, bro. This looks exactly like parts that I've made in the past. Specifically the, I've made this part before. That's so funny. It's almost identical to the ball. That's silly. It feels pretty strong, I'm not gonna lie. The 12s were definitely the right call. Okay, let's just see if I can get... This is so stupid. Alright, I'm gonna take it out. This would be so much easier if I, See, the problem is you can't twirl with this thing. You can't go hella quickly. Wait, well, how is that gonna help me? I don't think that's gonna help me at all. I need a, There we go. Is that how I want to do it, though? Is that how I want to do it? It's interesting because they call it rigging, which is a boating word. Let's see. Actually, you know, we could do this. Oh yeah, I never turned it off. We could just okay. But yeah, I could just go like this. You can see what I've got going on here. So I think what I want to do is maybe try to get this GRBL firmware working. That's something we can do while I wait. So, so we need a USB-A. What is this used for? This is a micro. I don't know if I have one. On my disgusting desk. Let's see. Okay, let's look up GRBL and just see. So GRBL, what is GRBL? Embedded high performance G-code parser and CNC milling controller that will run on a straight Arduino. Move to the new one. This should just work though, right? I'm bored, dude. I want to wait for this thing to 20 more minutes. Cook up. Let's cook up. Let's cook up. Let's cook up. Hey, let's cook up. It's good to be home, brother. Let's see, can we get this clicking? Why no click? Playing, right? Has it just not woken up yet? Wait, oh. Dun-dun-dun-dun. There we go. Oh, let me show you, bro. What's going on? Check it out. Dude, it's a little bit late for you, bro. Are you sure it's not morning? Alright, so here's what we got right now. So the CNC machine is coming along quite well. I'm just vibing, though. I'm just vibing, Ole. What is going on? So let me switch to this. So right now, we've printed and designed this, which is basically a linear rail. So this thing moves back and forth. It's hooked up to a motor, and then we have a belt here that we're gonna slide through. I just printed out this part, which will attach to this carriage here, and then I have a switch here. Can you see that? I have a switch here, and this switch, I guess I can just show it on here, will tell it when it's at 0. Bro, first album? Dude, I don't think you realize. We're on like the 11th album. Let's find out a personal favorite of mine. It's like lagging for some reason. I don't know why it's like jittery for me. Oh yeah, something is weird. What the hell is that? What? It didn't record it at all. What happened? Why is it doing that? Yeah, I gotta turn on the gain. Dude, Braid is sick. You know what though? I gotta say, Jonathan Blow is just like an angry man. Like, bro, he's just so angry. You know? I don't understand it. Like Jai, bro. And the thing is, everyone dick rides him for Jai. And it's like, I don't get it. I don't think it's all that special. I mean, like the thing about Jai. Wait, is it Jai? I'm pretty sure it's Jai. Yeah, Jai programming language. Wait, there we go. It just links to Jonathan Blow. That's the crazy thing. But he's so prolific. But what did he actually do? I mean, I guess he made Braid. That's like kind of the main thing he did. I'm sure he's a very nice in person. But it's just so funny. It's like you gotta beg him to use this programming language. This guy Soding loves him, bro. This guy on Twitter makes me so angry, bro. He's just like, but he's so famous, bro. He's so famous. He's like 100K subs on YouTube. Oh yeah, so what were we doing? I got distracted. I was trying to look up GRBL. Oh, Soding? This guy, honestly, he has some pretty sick videos, dude. He live streams too. He's probably like the most famous real coding streamer. Except for maybe George Hotz. He's probably the most famous streamer. Um Wow, this is his most. Wait, this is not the. It's Soding
Hello
Daily.
and well.
It's Soding Daily. See. Yeah, 141, dude. His most famous is like. Dude, I mean. He's such a memer. He's such a Russian memer. No, I know, but he's not an actual coding streamer. That's what I mean. Like, what is his name? The Primogen. He doesn't really code ever. It's more of an entertainment thing. It's more of like what drama is happening in the world of programming. It's not, I don't know. I've been watching it in a while, but from what I got from it, it wasn't like you're not really, Wait, hold on. I think it just finished. I'll be right back. Wait, no. Wait, what? Why did I get a notification that it finished? But yeah, he definitely tops the charts. The Primogen. I don't know if he... I don't know. No, I didn't get the DLC yet. I don't know, bro. I can't play games too much because when I don't know, dude, I just feel like games are not healthy, man. Like I play games and it's the best. But then I like get off the computer and I go sit in a corner and I'm like, bro, that was intense. I can't do that. It's just like it's so hard on the mind, I feel like. Like I'm not blinking for like 3 hours straight. But I do want to get back into Factorial. I at least want to dude, I saw, oh my gosh. I was watching this video though. This guy default settings Factorio speedrun. And he did so many smart things, bro. Like, oh, yeah, it was this guy Nephrums. Dude, this guy is so fucking lit. He does this thing where, like, before he gets electricity, he doesn't even build belts. All he does is he puts, like, all of his coal miners in a cycle. I don't know, he's so smart. And the way he uses Z is hella clutch. He's like, dude, he is so good. Yeah, the way he uses Z is so efficient, man. I want to use Z like that. All right, I guess he uses belts, but what I mean is he doesn't use belts for coal. Specifically, he doesn't use belts for coal. But anyways, yeah. What else did he do? I don't know if he got the trains. Yeah. No, I mean, like, I want to beat the game. Oh yeah, he did this thing with Oh, he also did this other trick that was really cool. I don't know why he did it, but if you look at these assemblers, he has like, I guess it's just dark. He has like, oh nice. All right, maybe I should just buy the DLC. Oh, by the way, I don't know if I said, but instead of this CNC machine being a mill, I think I'm gonna make it a pen plotter. I think I'm gonna do it like this. Let's see, where did the videos go? Um, like this kind of, or like this. This is my favorite video. Let's see. He has a demo of it. Yeah. So, yeah. Because I feel like it'll be. Because the thing is. Oh, and the thing that's so sick about this, guys, is he has a tool changer. None of these videos. Oh, here we go.
Hello everyone and welcome to this new DIY engineers video. In this video I'll be covering GRBL, pronounced gerbil, to be used along with your Arduino and Arduino CNC Shield module.
Alright, so I bought this.
That way you'll be able to...
This thing. And then it came with, actually, here, let me... Ugh. Dude, it's kind of crazy that an Arduino can power the CNC machine. Like, that's pretty nuts. Because I was looking to get it done with a Raspberry Pi, which is like, you know, it runs a full OS. And it's just amazing that like it's less supported. Like they have like it's possible you can get it done where you use a Raspberry Pi, but it's not nearly as easy as using an Arduino, which is kind of amazing. Because I honestly hate Arduino, mostly because Arduino, I don't like writing Arduino code. I like writing Python way more than I like writing Arduino code. Okay, wait. Oh yeah, so wait, I need to go get a USB cable really quickly for this thing so we can load the software onto it.
Alright, I'm back. I'm back.
Alright, let's see. Okay. Arduino. And I think I gotta get the Arduino software too. They have a cloud editor, which is honestly probably better. But whatever. Okay. Yeah, and then you gotta mess with the COM ports and stuff. It's just like, ugh, Arduino, bro. It's so cringy. But honestly, if it, saves me hours and hours and hours, then I don't really care. But I do want to save this. This thing is really nice. This thing is like the best. Yeah, it's just C, but it's like hardware abstracted C. So it's like, I don't know, it's just kind of a mess. It's really not so bad. I think I just don't. I don't know. I don't know why it doesn't jive with me, man. Let's see, X, Y, Z, A. Okay, so wait, we need to figure out. I don't know. We'll see if that works. But first we need to plug in all of the... First we need to plug in all the... What the fuck is going on? Okay. Alright, yeah, go to sleep, bro. We'll play Factorio soon. Are you doing anything for Christmas, by the way? Do you celebrate Christmas? I feel like the Polish probably do celebrate Christmas, but you? I don't know. Alright, good night. Let's see. Let's see. What am I doing here? I need to get these guys. You don't? Wait, where was that video?
Develop a machine like the one shown here in the video. In the video, I'll be covering everything in great detail, including the CNC Shield module pins, how to go ahead and connect it to your Arduino.
We only need one right now. What the hell am I doing?
Examples on how to program G-code to be used with GRBL. So let's go ahead and get started. GRBL, or Gerbil, is a free open source software that's used for motion control with Arduino boards that use the ATmega 328. This enables us to use an Arduino Uno to operate a CNC machine, such as a laser cutter, 3D printer, etc. Basically, we can use Gerbil and an Arduino Uno to operate any CNC machine with 3 axes, such as the ones I just mentioned. Specifically, you can make a custom CNC machine built from scratch to do this. Now let's talk about the Arduino CNC Shield. The Arduino CNC Shield basically allows you to easily connect up to 4 stepper motor drivers and 4 stepper motors to your Arduino project while connecting them to very specific pins in the Arduino. Then, the GRBL software, which basically you use with your Arduino.
Dude, what's going on with my audio?
Which pins each motor is connected to.
It's just driving me crazy.
Use the GRBL software to control your stepper motors in a very seamless way. Now, what if you don't want to use GRBL? Technically, you could use the Arduino CNC Shield without having to use Gerbil. Say you simply want to go ahead and have a project with a few stepper motors, and you don't necessarily want to use it for a CNC application, then you still use this device, and you can control X, Y, Z axis, A axis, which are not necessarily have to be axis, by using this and referencing the correct pins on your Arduino Uno. Now, as you can see, the Arduino CNC Shield has very specific locations for each axis on your CNC machine. There's also an A axis, which can be used to duplicate either the X, Y, or Z axis by using the appropriate pins, which we'll go over, or you could operate a fourth independent axis if you're not using GRBL, by using pins D12 and D13. Now,
Dude, something is screwy with my audio. I feel like it's still gonna happen. I don't know what's going on. There we go. Dude, why am I not using tools? I got tools. I got little tweezeros. Tweezeros. Okay, tell me what to do.
We're going to talk about the Arduino CNC Shield pins. If you look at this image, you will see that each of the axes, so X, Y, Z, and A, have their own spot to connect their stepper motor driver, such as the A4988, and stepper motor wires. On each of these spots, you also see pins to define the stepper motor micro step settings, as shown here. You can also see the ground pins on the right. For details on the A49 stepper motor driver micro step settings, please see my earlier video. Now on the left side, so over here, you can also see the pins to control the steps and directions of the X, Y, and Z axis. These are connected to the Arduino pins that are there if needed. But you shouldn't need to use this if you're using the Shield and Arduino via Gerbil, as the pins will, established will come from the pins within the Arduino. Here in the middle left, you also see pins that can be used to enable the A axis to mirror the X, Y, or Z, which are these. Note that when using Gerbil, you can only use the A axis as mirror and cannot independently control a fourth axis. With Gerbil, you can simply use all axes through the Arduino pins, as the one shown here, with a custom Arduino code. On the right, we have the pins for limit switches, which allow for both positive and negative end of the switches. And you also have pins to externally control the spin mode, which you have the enable and the direction. Note that if you're running Gerbil 0.9, the pin for the spin PWM control is D11, and D12 is the Z limit, so these are flipped on Gerbil 0.9, whereas this board, the one I'm showing here, is intended to be used for 1.1. There are other pins such as D12 and D13 for external control of direction and step of the A axis. You also have these other pins for enabling the coolant, abort, hold, resume, e-stop, as well as reset, another ground pin, serial and 8 2C communication, and a 5-volt and 3.3 volt out pins. Now, as I said before, there are two basic ways to use the Arduino CNC Shield. Either you're running Gerbil, or you're using an Arduino with regular Arduino code on it and representing the pins that I'm showing here. If you're running regular Arduino code, you're simply using the Arduino Shield to benefit from the fact that it's very condensed and you don't have a bunch of wires going all over the place. You could even control up to the 4 stepper motors, all within this board, without having to mirror, meaning independent of control.
All right, let me go get my 3D print. Where's the fucking? Oh yeah, bro. I lost the key. What the heck? Dude, I've gotten so bad about losing. Oh, here it is. All right. All right, nice. This part came out looking pretty good. Let's do a little test, actually, though. Let's get a belt. And let's loop it around on itself. Damn, I'm gonna have to reprint this. Wait. Wait, I might be a fucking genius. That's a tight fit in there. That's not going anywhere. It's actually kind of perfect. Here, let's get a good close-up shot. Okay. The lighting is terrible. I don't know. Okay. It's always so bad at autofocus. There we go. See that? If I tug on this, it's not going anywhere. Oh yeah, that's what you want. So how do we want to do this? So, okay, wait, we got to get this out of here right now. Should we use El Tuiceros? Seems fine. All right, I think I'm gonna use this. Ideally, I would. Ideally, I would maybe All right, so this is gonna go like this, and we are just going to use some M3 by 8s, which are always missing. They're always missing. They're always somewhere. These are the 12s. Here's the 8s. I'm only going to use 2 because I'm running low. I need to reclaim them from my bag of shame. I wanted to put a counterbore on here, but you know me, lazy AF. So let's just put 2 of these on here. Okay. Oh, wait. I'm stupid as hell. I forgot the threaded inserts. We want the limit. I want to test the limit switch. Okay. Let's here. Turn this on. And what did I say? They're M2s, so they're the biggest M2s. The thing is, do I even have M? Yeah, I do. Okay. Ooh. Okay. I wish I had autofocus, man. Like autofocus. Like I know I just have to click a button, but it's still too much. All right, so now what we want to do is we want to get our limit switch. So this is going to sit like this, and then our limit switch is going to go like this. Wait, like this or like this? Like this. I'm going to do it just how I catted it. Then you're going to get an M2, and then let's check the thickness of this thing with a caliper. Six. So we want at least 4, so 10. So let's use an M, like 12. Yeah. Yeah. Dude, I don't even know how they make stuff this small, man. It's like, how do you even get the threads on that thing? Fuck, I think I cross-threaded it. What the fuck is going on? Alright, we're gonna use the 8s then. I'm gonna use the 8s, because I think it's too... I don't know. I think it's not working. Let's try the 8s. Wait, I didn't even try the other one, though. Still not that far, so... Yeah. I mean, look, it's holding like a freaking 1 gram switch, so I think it's gonna be okay. Damn. Might be 1.5. Oh, yeah. One day builds, am I freaking right? CNC machine in one day. We're working up to the second axis. Don't. I got the rods. I think I'm just gonna use the rods. I'm not gonna. This rail cost me a bunch, so I'm not gonna use. I'm not gonna buy it again. It's like $35 or something. The rods were the hollow aluminum rods were like pretty cheap. Nice. Good stuff. You see that? Hear that click? All right, cool. Cool. All right, so now we need to belt it, baby. So let's figure this out. So I'm gonna cut this thing. I'm gonna undo it. I'm just gonna cut it. All right. Tape has been lifted. All right. So, so I think what I need to do, right, is I need to put one in. I need to put one in, and then I'm gonna like loop it through. No, that's not gonna work. We need to go like this. And then we need to go. This is gonna be tricky. Because I might have to cut it long and then cut it to the size I want. At most, it's gonna be. I mean, I have plenty of this stuff, so I don't really care about that. But at most, it's gonna be like this much. And then this much. So why don't I just do it? Why don't I just make the freaking call? Sometimes I get so bogged down on bullshit that I don't just do the thing. It's like, and I'll just give myself a little bit of extra right now. Okay. I mean, we got 5 meters of this stuff. I don't think it's going to be the worst thing in the world. Fuck this up. Okay, so now what I can do is because I should be able to pull it through, right? So what we're going to do is we're going to grab a little loop of this. We're going to flatten the hell out of it. We're going to flatten it like crazy. I'm going to flip this around. Get this cable out of here. I'm going to slot it in. And you're going to push it. Push it. Push it. Come on. There we go. Good shit. That's not going anywhere. Okay. And then we can feed this through. Okay. And we gotta feed this through. I should have made a window for the other thing. If this doesn't work, then I'll just reprint it. We gotta make sure the belt isn't up. Dude, I bought new stepper motors that have the freaking cable disconnected, and it's gonna be such a quality of life improvement for me. Okay, so there's that. Now this is gonna be the annoying one. Ugh, this is gonna be so annoying. Oh wait, actually I got it. I just have to use my tweezers. Oh yeah. Okay, then we just got to get it under tension. Yeah, we want it clicked in. Okay. So it's going to be like this. It's gonna be like this. And maybe a little bit more like this. That's too tight. We need to loosen it just a little bit. Maybe like this. A little bit less. One tooth less, maybe. Dude, this thing is so sick. In one day, I built a freaking almost CNC machine. All right. Hell yeah. Wait, it's too loose. Is it too loose, you guys? Too loose. We need to tighten it up. Come on. Come on. Get in there. Give me that. Oh yeah, that's tensioned. There we go, man. Check it out. Check it out. It's a CNC machine. Not really. But you know, we'll get there. Okay, so what I'm going to do actually is we are just going to use MicroPython for right now. So I'm going to get rid of this. We can do this later. We'll do this after. I just want to test that it works because that'll be very exciting. All right. All right. So we did it. Dude, I'm so fucking sick, bro. All right, so let's just get it running. I don't want to freaking mess around anymore. So we got this. We got this. I actually wanted, hold on. Put the fries in the bag. Put the motherfucking fries in the bag, bro. Alright, so we're gonna do this. Blue on bottom. Blue on bottom. Which one's enable? I guess that one doesn't even say. Okay, so let's just open up code. tinycnc. God, fuck. Oh wait. Ugh, I knew it wasn't gonna work. Ugh. Wait, what? Just what? Source, tinycnc. We're gonna move this to here. This is gonna be a repo. Ugh, it's so stupid. Okay, I have the bomb. I'm gonna go to my laptop really quickly. See, how great was it that I just made an executive decision? I was like, but also dude, it's like pretty straight. Like my back of the envelope math actually worked out. I think it's perfectly tensioned too. I don't even know what that was. Just Windows being Windows, obviously. Okay, so I'm gonna go push my code really quickly with the bomb and everything on it. So just give me a second. All right, cool. Okay, so let's just close this. Take this, go here, source, take this, delete this, go here, GitHub, origin, tinycnc. tinycnc. It's a tiny CNC. Oh, get clone, get clone. That's right. Okay. We do want to tape this up. Tape this up at least. Belt. Hold on. We got it. Wait, hold on. I forgot. We got Copilot for free, bro. Hell yeah. No, but is it? It's not. Oh, I have it. Hold on. Let's do pico.py. It doesn't do the it doesn't do the inline stuff though. Oh wait, hold on. Okay. From pin. I don't even know how to write in MicroPython. That's the embarrassing part. I've been doing this for so long, and I still don't know. So what we need to do is we need to take this thing though, and we need to plug this into yeah, like this. Very good. Very, very good. Okay, so we want to just let's just open up let's just go to Fusion Models. Damn it. Okay. Code Pico. Actually, where was that PID control for? Where was that PID control stuff? I thought I did it here. Closed loop stepper. I'm pretty sure that this is the code that I need. Fuck it, let's just try to run it. Is it the wrong? I feel like there's no way it's the wrong pins. Oh, you know what? It's that power is not. Did I unhook this power? Alright. 19 volts straight to the motherfucking dome. It just works. I don't know how many steps we want to go. wonder why it's... It looks like it's on the belt. So wait, here, let's do a little test video. You guys can take a look. It's my creation. I honestly can't help but think that it's so noisy though. If I hold this down, I don't know why it's so noisy. All right. You gotta think about this. You gotta think about this because where do we want the cables to go? Probably okay, and I can't help but thinking that maybe it is slightly too loose. Because why is it vibrating so violently? Is it something to do with the delay? Okay, well the limit switch is fucking annoying. But even still, it's really loud. Should I try to tighten it just a little bit more? Yeah, I'm acceptable with this amount of noise. Here, I'm gonna stop it and I'm gonna take out the just so we can get a sense of because no amount of tightening it down is going to let's run it again. I'm gonna tighten these down. I don't think I tighten these down. Yeah, I don't know what that chatter is coming from. I think I'm gonna take it out. I think I'm gonna like try to like get just another tooth from the bottom there. No, but you can't put too much. There, that's the tooth. Mm. Okay, I feel like that's probably even looser. All right, well, I loosened it then. Let's see if it's quieter now. I'm trying to figure out what is making so much noise though. Well, we can't take the freaking. Oh, it's just that it was too slow, guys. Oh, this is so much better. It's so beautiful now. Okay, this is a belt-driven linear rail NEMA 17 stepper motor, and then a A4988 with a Raspberry Pi Pico. Soon going to be using an Arduino with a CNC shield, but for now, at least we got the linear rail working with the GT2 belt. Wait, I actually want to do it like this. Alright, we got a GT2 belt-driven linear rail using a NEMA 17 stepper motor, Raspberry Pi Pico, and an A4988 stepper driver. Soon we're going to be using this Arduino Uno shield that is a CNC driver. So soon we're going to be turning this thing into a CNC pen plotter. Stay tuned. I'm going to post that shit, but oh, it's so much better now. What if we just make it like basically nothing? Right, it needs some. I guess we were just hitting like a resonant frequency or something. I don't even know. Alright, so let's clean it up a little bit. Let's snip that extra little bit. I'm gonna leave some, but not a ton. Alright, it was literally $10. I don't know why I'm freaking out about it. Alright. Ow. Pretty cool. It's a few 3D printed parts and you can build this thing. And okay. I feel like it's getting late. I feel like that was a good stream, 6 hours. I didn't really do much, but you know, we got a few parts done. It's pretty cool, I think. All right. Well, you know what? I'm being kind of a bitch. I mean, like, we'll do the limit switch thing tomorrow, but let me at least figure out what this gerbil shit is.
Next, we will install the Arduino Uno. This is loaded onto the stand box in the print and secured in place with some M3x6 bolts. I only have mine in a couple of places. Your set motor drivers might come with heat sinks already attached, or two separate items for you to attach yourself. Now they're not attached, just peel off the sticky back and place it carefully onto the centre of the board. We can then attach one to the X and to the Y axis on our CNC shield. Make sure that when you insert them onto the headers that they are oriented correctly. There is a pin on the motor driver labelled as EN for enable, which will line up with the same marked pin on the CNC shield. The wires coming from our barrel connector are then added to the terminal block on the CNC shield, paying attention to the correct polarity as marked. The wires on the fan are then connected to the 5-volt and ground points on the CNC shield, found behind the power supply terminal block.
Wait, hold on.
Connector are then added to the terminal block on the CNC
Yeah.
shield, paying attention to the correct polarity as marked. The wires of the fan are then connected to the 5-volt and ground points on the CNC shield found behind the power supply terminal box. We'll add wires for our contact switches next. Now there are several ways of connecting these to a CNC shield. You can either solder them directly to the pins, or you can add some female DuPont connectors to the ends of the wires. I have added some female DuPont connectors to my wires as I wanted to be able to reuse the shield while designing a prototype for this project.
That's where I know this guy from, is the freaking DuPont video.
Add your own DuPont connectors to wires. Now I've made a separate video showing you how
Oh, that's where I know this guy from, dude. He's a legend, man. Yeah, you guys just saw me grab my balls.
And then connected to the white and black pins adjacent to the end stop connection labeled X- on the board. The wires on the contact switch on top of the bar are also passed through the same hole in the lid before connecting to the white and black connections adjacent this time to Y-. The orange wire from the servo connects to the black pin next to step plus, the brown wire to ground, and the red to 5 volts. The Y-axis motor, this is the one from underneath the rod, is passed through the centre slot in the lid and connects to the row pins for the Y stepper driver on the CNC shield. The red wire should be closest to the outer edge of the board. The X-axis motor cable passes through the other hole and onto the row pins next to the X stepper driver. The CNC shield itself can then be inserted on top of the Arduino, taking care to align the pins. The lid can then be loaded in place, being careful not to trap any wires, and secured with 4 M3 by 6 bolts. Okay, so that's our hardware finished out. Join me in the next video where I'll guide you through how to install and configure Gobble onto the Arduino Uno.
Gobble.
Hello, and welcome to part 2 in my guide on how you can build and assemble your own mostly 3D printable, open source CNC drawing machine. In this video, I'll go over the software and settings used on the Arduino Uno to run the machine, as well as a short demonstration on how you can create your own G-code for your own machine. First, and by request, here's some more information about the CNC machine and how it works, and shortly afterwards, we'll dive into the software side of things. The X-axis, the one which runs side to side, is controlled by this stepper motor and a timing belt. In a similar fashion, the Y-axis, which goes forward and backwards, is controlled by the stepper motor underneath the platform. The Z-axis, which is the one that moves the pen up and down, is controlled by a small servo connected via a timing belt. The finger dials on the front make it very easy to change the pen without the need for any tools. The Arduino and other electronics for this project are housed in this container, which is kept cool by a small fan. This
Beautiful.
makes it very easy to pack up or move your project elsewhere. If you haven't yet seen part 1 of this video series, which covers 3D...
See, I just wish I was better at doing this.
I've also put one in the description below. Now, this video is going to be a little bit more wordier than mine usually are. This is because I'm going to endeavour to show you how to test your machine as you go through each step. This will help you spot any problems before they get very too deep, and it will give you a better understanding of how exactly your machine works.
Alright, let me get the linear bearings. Well, actually, no, I'm gonna be gone.
Which will be pronounced as Gerbil, Gerbil,
Actually, no, I won't.
GRBL is some free open source software which is used to control CNC machines. It's ideal for our project. However, it's designed to control machines which have a spindle or laser attached to their heads. We will be using a servo in our machine to power them up and down, so we're going to run a modified version of this software. This is called MeGurble. You can find a link to download this software and any of the other software that I talk about during this video in the description below. Download the Gurble folder, unzip it, and then copy it to your Arduino's library folder. On a Mac, this is usually users/your name/documents/Arduino/libraries. And on Windows, it's usually something like mydocuments/Arduino/libraries. Open the Arduino IDE, again, links download this are in the description, and in the menu, go File, Examples, Gurble Me, Gurble Up.
Alright, just got some linear bearings.
Your computer using a USB cable. Select the Arduino Uno board
You definitely need bearings.
library folder.
I used to think bearings, I was like, why do I need bearings? You need bearings.
During this video, in the description below, download the Gurble Me folder, unzip it, and then copy it to your Arduino's library folder. On a Mac, this is usually users/your name/documents/Arduino/libraries. And on Windows, it's usually something like mydocuments/Arduino/libraries. Open the Arduino IDE, again, links download this are in the description, and in the menu, go File, Examples, Gurble Me, Gurble Upload. Connect your Arduino to your computer using a USB cable. Select the Arduino Uno board type in the Tools menu, and the correct port for your Arduino, and upload Sketch. Once the upload is complete, you can open the serial monitor and set the baud rate to 115200. Sending $2 should return Gurble's current settings. To begin with, we will upload a set of configuration settings for the designs I have built here and have shown you in the first video. We will use this to check that the motors work properly and that our limit switches are responding as they should as well. I have put a link down in the description to where you can get a copy of these configuration files. Copy and paste the settings line by line into the Arduino serial monitor, and they will automatically apply themselves to your Gurble installation. You can verify this by sending the double $signs again to see the current configuration, which should be different to what we saw earlier. As a quick side note, the configuration for Gurble is saved as a non-volatile memory on board our Arduino. This means that it will be remembered when we power up our Arduino and power it back on later. So don't worry about trying to reload your configuration every time you switch your machine on again. Before we begin testing the hardware, gently...
Well, that's nice to know.
So the head is roughly in the center of the expected working area. As we have some honing switches configured on our CNC machine, when we first switch it on, it will start up in an alarm state. This is because it cannot be sure at the moment where its head is in relation to the rest of the machine. To resolve this, we will trigger a honing sequence, which will move both the X and Y axes to their very ends until they are in contact with the limit switches. These two switches are located here and here. We will issue the honing command to our Arduino in a moment, and what we want to see happen is the axis to move all the way to the left and all the way to the bottom left corner of our drawing area until it engages those two contact switches. At this point, it will perform a small bounce on the two contact switches to improve its accuracy, and then we will read OK in the serial monitor. Be prepared to disconnect the power if your machine does anything other than this. If it does, recommend going back to the part 1 video and checking your work, paying attention to the electronic connections so far. Look at my website for some FAQs on this project's page to fix some of the most common faults you might come across. If it works just fine though, we'll move on to testing the survey's ability to move the pen up and down in its slider. To do this, issue the command M3S90 followed by M5. The servo should pull on the timing bell and raise the slider when M3S90 is issued. This should have fitted the pen slider upwards very near to the end of its travel, and our servo should not be continually strained to try and pull it any further. If it is, refit the timing bell inside the 3D printed arm on our servo, giving it a little bit more slack. As you may drop the position of the machine since issuing the first honing command, we issue the $H, and then once honed, issue G92X0Y0. This tells the machine that wherever it is now should be known as the origin by setting its current location as 0 on both the X and Y axis. If you would like to move both the X and Y axis manually using Garble, then this is a great way to test how everything is working so far. To do this, we can manually issue the following command: G1X10Y50 F2000. Let's break this down.
2,000 feet, bro? What the fuck are you talking about, bro?
And the number after F, which stands for feed rate, tells the machine just how fast to move.
Whoa, 2,000 feet?
Now that we know that's working fine, we can set our computer up to automatically feed our Arduino G-code lines so that it's able to draw a much more detailed drawing than we could by issuing command ourselves. The G-code sender which we will use is a web application called Chili Pepper. Head on over to its website, chilipepper.com/go. I'd recommend using Google Chrome for this. The first thing which we will need to do for Chili Pepper is install a JSON server onto your computer. This is just a small program which helps your web browser connect to your Arduino via the USB port. To do this, follow the download serial port JSON server link in the lower right and download and install the correct version for your operating system. Ensure your Arduino is plugged into your PC before starting the program. Go back to the Chili Pepper window, reload the serial port list with this button, and you should now see your Arduino. Select Garble from the drop-down list, and check that the serial speed is at 11.5200, and then check the box to its left to select it as an output. Go open the axis window if it's not already expanded, and press Home Axis to check that it's correctly connected, and then press 0 out to reset the coordinates. The Home Axis button issues the same $H command that we used earlier to start the honing sequence on our Go machine. The 0 out button also uses the same G92X0Y0 command that we also used earlier. Before we add pen and paper to our machine, it would be a good idea to do a dry run first. To load the G-code file, dyn-test.gcode, which is linked to in the description below, just drag and drop the file onto the center preview area of Chili Pepper. Then press the play button on the left-hand side.
Wait, what happened?
Issues the same. Select it, select Garble. Go back to the Chili Pepper window, reload the serial port list with this button, and you should now see your Arduino. Select Garble from the drop-down list, and check that the serial speed is at 11.5200, and then check the box to its left to select it as an output. Go open the axis window if it's not already expanded, and press Home Axis to check that it's correctly connected, and then press 0 out.
This is a really nice... Dude, what a nice little controller.
That we used earlier to start the honing sequence on our Go machine. The 0 out button also uses the same G92X0Y0 command that we also used earlier. Before we add pen and paper to our machine, it would be a good idea to do a dry run first. To load the G-code file, dyn-test.gcode, which is linked to in the description below, just drag and drop the file onto the center preview area of Chili Pepper. Then press the play button on the left-hand side to begin streaming these instructions over to your Arduino. If all is gone well, then we can take down some paper and add a pen to our machine to make our first drawing. To install the pen at the correct height, we'll need to ensure that the slider is raised. If yours is not currently, then this can be achieved by issuing the command M3S90. Insert the pen so that the nib is about 3 to 5 millimeters.
M3S90? The spindle speed is for the... That's so goofy.
Now that that's a success, the next thing to do is to show you how you can create your own G-code from your own drawings for your machine. For this, you'll need to download version 0.48.5 of Inkscape. This is free and there's a link to it down below. After you've finished downloading and installing it, we then add an extension to it called MeGarble to help turn our drawings into G-code which our machine understands. Download the files linked below again, unzip it, and then copy the 4 files inside to c/programfiles86/inkscape/share/extensions, overwriting anything if a warning dialog box appears. We can start Inkscape and set the size of our drawing area by going to File, Document Properties, set the default units to millimeters, and in the custom size, set the units to millimeters again, and then enter a width of 225 and a height of 250. A good good first drawing to show the basics would be to draw a box about the size of our working area and use a Sharpie to mark this out onto the baseboard for reference in the future. Click the box tool and draw a box just slightly smaller than the entire drawing area. Change the fill colour to nothing by left clicking here, and hold down shift and click black to set the stroke colour of the border. In my experience, a Sharpie fine line draws a line about 0.8mm thick, so we'll also set that so that we can see a better representation of the drawing on our screen. To do that, open the stroke and fill window by clicking this icon or pressing Shift-Control-F on your keyboard. Click Stroke Style and enter 0.8mm. Only strokes get converted into G-code for our machine to draw with this plugin, so we need to select the box and then go to Path, Object Path. To export this to G-code, we simply click Extensions, Amigo Z-Axis Servo Controller. For your first time, we'll need to change a few of the values as shown. Servo up to N.
Whoa, Inkscape has that built in? What the hell?
10,000, Y-axis speed 4,000, angle for servo 90, a delay 0.2. This is the part where you want to save the encoded file, and this, well, it's the file name. We can then home our axis on Chili Pepper, zero out the coordinates, drag and drop the G-code onto the main Chili Pepper window, and then press play to do a dry run first. If the dry run went well, then you can add a Sharpie and play the same code again. And now we have the boundaries of our CNC machine clearly marked out for us. To create a block of colour in these drawings, in Inkscape I created a pattern of lines spaced closely together. This is how I created the blocks of colour used in my Avengers character. You can now go ahead and experiment with some different types of mediums. As some examples, here's some Sharpie pens on some paper, the same Sharpie pens on the back of a white silicon iPhone case, and some edible ink pens on top of a sheet of icing. I have created a set of machine-ready G-code drawings for you to draw on your machine. To help financially support this channel, you can download them in exchange for a small donation by following the link in the description of this video. You can also support my channel by becoming a patron, just the same as these lovely people here have. Thank you for your support if you're watching, and if you become a new patron of mine, thank you.
Dude, what a fucking god. Such a legend, dude. He's using different drivers. I don't even know if you need a fan, man. Alright, that's it for the stream. So what did we get done? We got this linear rail thing working. Pretty cool.